Hey Razor.
Hey Arnim, what's up, man?
Yeah, I'm doing good. How about you, man?
All good. Just
Hey Razor.
yes, I can see you now. Hey
Yeah,
Arnim, what's up, man?
yeah, I'm doing good.
Hi, man. Yep. Can you see me? Good. Just yes, I can see you now.
The voice seems like echoing.
Yeah, it's fine now, right?
Yeah, right.
Great, great. Yep. So yeah, all good, and we are ready to rock the day too.
Yes.
And I guess we already have Josh with us.
Yeah. He's backstage
Can we
awaiting
have him on
us
the
to get
screen,
over.
please? Yes. Hi,
Hey,
Josh. How
Josh.
are you?
Hey, great to be here, guys.
Yes, so good to see you. And what's that number? 5,000? Like, is that the cheese slicer that you have eaten?
Oh, that's something from the startup I was
Okay,
working at
that's
before.
cool. So yeah, according to the IST, it's been a very early morning, I guess, but it's pretty late for you, right?
Yeah, it's evening here, so it's a good way
Mhm.
to end a nice day.
Right. So yep.
Had
And
some
starting like first of all, I want to know, like, I keep aside the entropy and all. I want to know what's your favorite jutsu move.
jujitsu move.
Yes.
I was at practice this morning, actually, in the afternoon. I like the triangle choke. It's
Okay,
a
that's cool.
it's a
Yes, just a
chokehold.
brief introduction about Josh. He's like one of the coolest guy that you ever found on internet. Is probably doing like in the morning. I don't know, probably jitsu in the night. It probably is skateboarding or something. But yes, so he's like doing all the extracurricular activities, all the extreme sports. As a very sporty guy, and besides that, he runs his chain goods and delivers exciting information to the community. And he is so knowledgeable and always be supporting community with his extreme knowledge. So here we are with us, Chain Goods and Mr. Josh itself from Microsoft, and he will be sharing his research or you can say knowledge about the entropy, which we all need to learn about. So the stage is all yours, Josh, and we are pretty
Well,
excited.
well, thank you guys so much for having me. I really love the work that you guys are doing, and it's always really cool to be a part of the community that's here. So, yeah, today we're gonna talk about getting random entropy and its uses in cryptocurrencies. So, um, thanks for the introduction. Like you said, I'm a software engineer at Microsoft. I do sort of like back end and systems programming for my day job. And on the side, I just love sharing knowledge of computer science with people, kind of breaking down and making topics, hopefully easy to understand for non technical through computer science people. Just, giving all those little breakdowns about interesting topics in cryptography and computer science. So today we're going to talk about entropy, and why is this interesting? Why is this important to us in the blockchain space? Entropy is something that even outside of cryptocurrency is super important for all the cryptography we use day to day to secure our web browsing and secure our data stored on our hard drives encrypted at rest. And broken randomness can break cryptographic systems in really interesting ways. So we're going to talk about the different ways that we use random number generators and random functions in blockchains. And aside from some of the obvious ones, there's some interesting use cases that folks might have not thought of before. So hopefully, it's an interesting dive into why this topic is so important. So entropy in a computer science sense is a little bit different than sort of the definition we use in physics. Physics is kind of the degree of disorder in the system. They say that, our universe is always full of entropy and unpredictability. But in a computer science sense, we're talking about randomness collected by computer systems for use in things like key generation, nonces, and those kind of use cases. And there's really different sort of levels or categories of randomness for this purpose in computer science. So let's kind of talk about those. There are true random sources that can actually be captured in computer science sense for use. There's non-cryptographic pseudo-random numbers, and there are cryptographically secure pseudo-random number sources. And that's kind of what we are usually talking about when we're talking about applied cryptography. There are some sources of what we would call true randomness in the universe. And one of those sources, which I think is kind of interesting, is radioactive decay. So like certain, atoms and isotopes, I'm not a physics guy, right? But they break down in ways that are considered to be truly unpredictable in the physical universe. And this entropy actually is possible to record by computers. People have built prototypes of true random number generators that use things like radioactive decay. But the problem for computer science folks is this is generally pretty impractical, right? We can't all carry around radioactive isotopes in our phones or in our computing devices. And not only that, but these systems can also break. And if a true random source like that breaks, it breaks our random number generator. We can have predictable keys and those sorts of things. So even though this is a possible source of random numbers for computing, it's not a practical one. So instead, when we're talking about computers, we generally use what we call pseudo randomness. So instead of relying on true physical universe sources of entropy, we rely on random algorithms instead. Now, there's kind of a problem with creating random functions, and that's the fact that, sort of opposite to, radioactive decay or something like that, computers are very, very predictable machines. We know as computer scientists and as programmers that computers do exactly what we tell them, right? They execute functions exactly. And so it's actually quite difficult to harvest randomness. But we've come up with solutions for this. And there's two sort of different broad categories of algorithms for getting random bits out of a computer. There's regular pseudo-random functions, and then there's pseudo-random functions that are considered cryptographically secure, meaning that they're usable for purposes like key generation. So I put together a little program in Python that generates a bunch of random numbers, one using a non-crypto secure PRNG, and this very commonly used algorithm in most programming languages called the Mersenne twister. And on the right-hand side of the slide, I have numbers generated by a cryptographically secure source that's provided by the operating system. And in this Python script, that is made accessible to us through the os.urandom API. So these are histograms showing the distribution of random numbers generated out of, like, say, 100. I think I did 100,000 numbers here. What's the difference in looking at these two graphs? It's not immediately obvious. The distribution of these random numbers seems pretty even. So we have a good distribution of randomness through the non-crypto secure source, the Mersenne twister, and we have a pretty good distribution with the crypto secure source. Well, the answer, the difference between these two types is the fact that it's not just about a uniform distribution of the random numbers. It's not about the fact that if you generate 100 random numbers, where they fall on the spectrum of 0 to 100. It's also about the predictability of new random bits. And what I mean by that is if you're given a set of random numbers generated by this random function, can you use that information to predict future bits that will come out of that random function? So for example, the very popular Mersenne twister, which is usually what you get when you use a programming language's built-in random function. Given a certain amount of random numbers generated, you can actually very reliably predict the next random numbers that will come out of that. So, even if you seed your random function with, say, the millisecond time on your computer, given 624 is actually the exact number for the twister, you can predict reliably the next numbers to come out of that function. Now, for a crypto secure random source, no matter how many random numbers you take out of that source, you can't predict in any way what the next bits will be. And that's actually really important for key generation and that sort of thing. If we're gonna say have a server that's gonna say it's a server for Coinbase or server for some other crypto exchange or web wallet, and we're generating a bunch of keys for hundreds of thousands of users, it would be really bad if an attacker got some subset of those numbers and then could predict all of the new keys that were generated. So, again, that's very, very bad from a security perspective. So for key generation, we need to use these crypto secure sources. Now, how do these crypto secure sources actually work? They use a mechanism that I kind of like to call, as an easy way to remember, seed and feed. Again, computers are really predictable by nature, so we still need to, for our random functions, harvest some amount of random data from the environment around the machine. So we can use relatively unpredictable environmental sources. Common ones include mouse movement, like jiggling your mouse around as you go about your business on the computer. The key press timings down to millisecond or microsecond intervals. Phones, use accelerometer data as part of how they feed their RNGs. You can even use things like temperature. Beyond that, for the extra paranoid, you could even feed a CSPRNG with something like dice rolls, right? Something that's physically very random, or shuffling decks of cards and feeding that into an algorithm. There are tools out there that allow you to do this for things like, creating crypto wallets or creating diceware passwords. And then what we do is, even collecting all that sort of randomness isn't generally good enough to directly generate keys. So what we do is we feed those sources to a secure cryptographic function. And examples of things that could be used for this are things like the SHA hashing algorithm, or, as is often used from my understanding, things like an AES block cipher in counter mode or some other mode that works for this source. A production example of a CSPRNG is the Fortuna RNG, and that's something that's detailed in books like Practical Cryptography, other online sources that you can read about. And the important thing is that we always get unpredictable random bits out of these functions. Our computers constantly need sources of randomness. Like every time you visit a new web page and you're doing a TLS handshake, you're generating new keys and those sorts of things. So our random functions, our operating system that exposes this API, is always taking in new sources of entropy from the environment, like your key press timings, and then using that to feed these cryptographic functions. So I made some little standalone examples. They're not like production ready, cryptographically secure things, but demonstrating these concepts. One of them is a diceware password tool, where you can roll dice and input the dice rolls, and it'll show you the entropy in bits and give you words that you can string together to create secure passwords. Another example is a entropy collector that uses an accelerometer. So it collects a bunch of data from your random movements at short intervals and feeds them to one of these cryptographically secure functions. So it's really interesting to kind of see examples of this and break down on a more macro scale how these algorithms work. So now that we have a good idea of what random functions look like, let's talk about some uses of cryptographic randomness in cryptocurrencies. There's a couple different places where we need to use randomness in order to build secure systems. The obvious one is key generation, right? Private keys are the core of crypto ownership. That's what allows us to be our own bank, so to speak, is we can hold our own keys. But they're also important for signatures, and they're important for our consensus mechanisms. Proof of work and proof of stake both use randomness at the core to secure the system. And of course, we're going to talk about what happens when these things break, which I think is the interesting part, like why it's so important that we get randomness right for these functions. Again, key generation is the first, I think, obvious use case. Private keys are the core of our crypto ownership. Your keys, your coins. Not your keys, not your coins, as we often say. And it's critically important that these keys are random. Keys themselves, for pretty much every major cryptocurrency that I know of, are 256 bits. So your Ethereum address, your Bitcoin address, your Litecoin address are backed by a private key that is 256 bits of random data. Now, there's a caveat to that somewhat, is usually seed phrases are 12 to 24 words, and a 12-word seed phrase starts with 128 bits of entropy. And that entropy is stretched using a key stretching function that turns it into, a 256-bit key. And there's a lot more that goes into the bit 39 and bit 32 and bit 44 standards that I'm not going to touch, but we're generally starting with anywhere from 128 bits up to 256 bits of entropy from a random source. That could be generated by your PC if it's a desktop wallet. It could be generated by a server if it's something like an exchange or a web wallet. And it could even be from a random number generator built into a hardware wallet. And the cool thing about the hardware wallets is that random source is built into a standalone device, and the keys never leave that device. I mean, all of us crypto security folks love to recommend people use those kind of offline devices because there's less of a chance of those keys being leaked or even the randomness used to generate those keys being leaked in any way. Now, you may be wondering, is 256 bits enough? Is that enough entropy to make sure nobody can ever guess my key? And the answer to that is if it is securely generated from a crypto secure function or even something like, good dice rolls, yes. That gives us the numbers between 0 and 2 to the 256 power minus 1. And that's a really, really, really big number. I'm kind of baffled by the math, right? 2 to the 256 power is somewhere on the order of the number of atoms in the observable universe, at least what we think is. Think about how many atoms are just in your phone or your table. I mean, it's just a number that is so big that human beings can't comprehend how big that is. So what happens if the keys aren't random enough? The answer is, I think, somewhat obvious, is a key that's not random enough is pretty much the worst case scenario for a crypto user. That if your key is not strong enough and somebody can guess that key, the attacker can steal your coins. Because at the end of the day, anybody that has your seed phrase or your private keys controls those coins as much as you do. So one of you is going to move them first, either you or the attacker. And, if you have a poorly generated private key, the attacker can then take the coins, move them to an attacker-controlled wallet in a new transaction. Now, what's a practical example of this? A very good practical example of this poor key generation is what we call brain wallets. This is the idea of generating your own passphrase. So not using a secure function to generate 256 or 128 bits, but rather coming up with a password, say, desk, microphone, phone, laptop, hashing that through SHA-256, which will give you a 256-bit number, and using that as the 256-bit private key. Now, there's been a ton of research into how bad these are and how poor humans are at entropy. Ryan Castellucci, a researcher, did a phenomenal DEF CON. It's not even passphrases that seem like they would be okay. I mean, brain wallets that used long passphrases from things like movies, quotes from movies, quotes from books in different literature, have had their funds stolen. There's a whole network of attackers that do nothing but try to crack brain wallets and race to steal the coins in them. It's really important to remember human beings are bad at entropy. Even though we said computers are bad at entropy at the start, we can at least use secure algorithms through computers, but people trying to come up with randomness rarely works out very well. Another important use of entropy in cryptocurrencies is through signatures. So every transaction has to be signed by the person that controls the wallet. So if I want to send, an Ethereum donation to the RazzorSec team, I would have to sign a transaction to do that donation. And these signatures, the algorithms that are used to generate these signatures, require a random nonce for every transaction. And this nonce must be one-time use. So we use SecP256K1, an elliptic curve algorithm for Bitcoin and Ethereum, and again, pretty much every major cryptocurrency that I know of, because of its efficiency and the fact that it has small keys compared to, something like RSA. But nonce reuse can easily reveal the private key. There's some sort of math that you can do if you have two different signatures that reuse the nonce. It's actually fairly trivial to compute the private key from that. And there have been, capture the flag type activities that demonstrate this. And again, I have a small sort of standalone tool called Not OK Reuse that is a demo of this concept. So there have been instances in the past, and I don't remember the wallets off the top of my head, but where sloppy wallet programming led to nonce reuse and therefore attackers stealing funds from the users of those wallets. Now, some perhaps less obvious uses of randomness, besides just key generation or signatures, is our consensus mechanisms, our decentralized consensus mechanisms that we use to secure our blockchains. Both proof of work and proof of stake rely heavily on entropy. We have to make it difficult for an attacker to change the state of the blockchain and to sustain that attack over time. In other words, we need the block winner, the validator or the miner that gets the block to be chosen at random, and random in a cryptographically secure sense. But at the same time, we also want to reward those that invest in more mining hardware, so hash power, or more stake for proof of stake systems with a higher probability of being selected. And there's some kind of interesting mechanisms that allow us to have both of these properties, where it's very difficult for an attacker to guess and sustain an attack on the network, but also for us to wait and sort of favor folks that invest more into the networks. Proof of work uses the pseudo-random property of cryptographic hash functions like SHA-256. So Bitcoin, of course, and Bitcoin forks use SHA-256. Other blockchains like, Litecoin and some others use, password generation functions and that sort of thing. There's lots of different hashes that have this property of cryptographically secure pseudo-randomness. So for proof of work, we require a block, a proposed block from a miner, to have a certain number of leading 0 bits. Say, for example, we want to have 4 leading zeros in our hash. And it turns out that the higher the difficulty, the more leading zeros we have, the more guesses on average it takes for a miner to find a block. So the mechanism here is, still a little bit difficult to understand if you're new to cryptography, but also fairly simple. The more hash power you have, the higher chance you have of being the first to guess a block nonce that gives us this desired amount of leading 0 bits. Now, 4 would actually be a very low difficulty for a real blockchain. The real difficulty, values are much, much higher. So, for example, in Bitcoin, the algorithm is designed so that with all of the mining power on the network, it takes on average 10 minutes for the miners to find a block, to find the correct nonce that gives us a hash value with a certain number of leading zeros. And all of this is built on the fact that SHA-256 is a strong pseudo-random function. When you put something through SHA-256, you always get the same output, but there's no way at all to tell, based on what the input is, what the output value will look like. So if you hash hello and you hash hello1, you get 2 very different SHA hashes. And that's what allows this proof of work mechanism to work, is you have the block data for all the transactions in the block, sort of hashed up into the block header. And then you have miners trying to guess some random value that when appended to that and run through SHA, you get a output value that matches the difficulty requirements. Now, proof of stake also uses a mechanism that I think is very, very interesting. And I was actually learning about this fairly recently as sort of my deep dive into entropy and its use in blockchains. Proof of stake, again, uses the pseudo-random property of hashes like SHA, and they use something called a commit and reveal scheme to generate random numbers on the blockchain. So with proof of stake, instead of having miners doing a bunch of guesses, you have what are called validators. And these validators stake their coins. They say, I'm going to put up 32 Ethereum as collateral as sort of an honesty test that they're going to try and validate blocks that follow the rules. And if they don't follow the rules, they can have their coins slashed. So that's sort of the incentive for stakers and validators to do the right thing. Now, how do you get a bunch of validators to work together to pick one at random, right? How can we avoid gaming the system? So a validator, which it runs on a node, generates a random number from its operating system cryptographically secure source. So just like it would generate, a key to do something on a web browser, it generates a random number. And what it does is it hashes that random number and commits only the hash to the blockchain. This is the commit phase. So at the start, none of the validators know what each other's random numbers are, but they have the hash of that random number. And of course, a very important property of our crypto secure hash functions is that they're not reversible. So if I give you the SHA-256 hash of something, there's no way to go from that hash back to the input data without literally guessing the input data and feeding it through the hash and trying to work backwards, which is how password cracking works. Now later, all of the validators reveal their random numbers. And all of the other validators on the network can then make sure that the other nodes were honest by simply running that now public random number through the hash function and verifying that it's the same hash that was committed. So, if I generate some random number and let's say it's, 1, 2, 3, I put the hash on the blockchain, and later at the reveal phase, I reveal that it was 1, 2, 3, and all the other nodes run 1, 2, 3 through, the hash function, and they say, okay, that matches the hash that was put in at the commit phase. And then all of the validators sort of XOR the numbers together, and they get a pulled together source of strong entropy that can be used for the validator selection. And there's further work that goes into weighting who gets picked as the validator, because the idea is you want it to be random so that anybody on the network has a chance of being picked as the validator. But you also sort of want to favor validators that are willing to put up more stake. So it's just like in proof of work, the people that put more hash power into securing the network have a higher chance of guessing. The validators that are willing to stake more of their coins, like Ethereum, will have a higher chance of being picked as the person that gets to validate the block and get the block rewards. So with this mechanism, it's impractical for nodes to game the system in their favor since they can't easily change their number after the commit. Once they commit a hash to the blockchain, they're not going to be able to go back on their word because all the other validators will say, if you try to come up with some other random number that gains the selection in your favor, you're not able to, change the hash. It's not practical to find a hash collision with any modern crypto secure function. So we have a function as how often does the validator RNG generation happen for every epoch? To be honest with you, I don't know the answer to that question off the top of my head. If I had to guess, this would be done for every block, but I'm not sure. So that's something I would need to look up and investigate further. That's a very good question. So thank you, Davis, for that. So in summary, it's important that we get random for this stuff. There's different types of RNGs, and the ones that we need are cryptographically secure sources. So we need to use proven systems. Use your OS's random source, right? If you're on Linux, dev/urandom, Windows has CryptGen random. Use proven systems, right? It's generally a very bad idea to roll your own crypto. And it's important if you're developing software to be cognizant of what random API in your programming language is crypto secure versus the one that's not. I said earlier in the talk, the random function that most programming languages offer built in is not a crypto secure source. Like rand in C is, I think based on Mersenne Twister. It's certainly not crypto secure. Python's random function, random library is not crypto secure. And there's valid use cases for those, for things like, simulations where you do want, your numbers to be uniformly distributed, but also predictable for research purposes. But for crypto purposes, we need something like Python's os.urandom. So that source is one that uses the underlying OS random number generator. Random numbers are, critical for obvious things like key generation and nonces, right? Super important that we have secure keys for our private keys for crypto. But they're also critical for things like our consensus mechanisms, proof of work, proof of stake, even other consensus mechanisms that are out there use randomness in some way. Because again, we don't want people to be able to game the system in their favor and change the blockchain. It has to be hard for an attacker to start and sustain an attack on the decentralized blockchain. Getting random wrong has very serious consequences. Of course, the biggest one being coin theft and other consequences like an attacker being able to, gain control of the system through something like a 51% attack. I mean, it could be a 100% attack if, we find out that SHA or some other hash function that's used in these systems is broken. So, of course, I always like to end the talk. Anybody have any questions in the chat?
Hey Josh, that was a wonderful session. I actually got a lot many facts and figures from your talk. So yeah, that was pretty nice. See, like some like one or two questions that I had that I can actually ask you. That would be much better. So what do you think about the Chainlink VRF that we use? So is it reliable enough right now, or we have some considerations about that as well?
So you said Chainlink?
Yes, Chainlink VRF.
I have to be honest. That's kind of another question. I don't know a ton about Chainlink. My guess would be is, these sort of Oracle systems probably use something similar to like the proof of stake consensus mechanism, where they're getting a bunch of random sources from different sources on the network and, putting them together in some way that an attacker can't reliably control. That would be my intuition, but I don't know exactly, how they do it.
Right. Yes, kind of like that. Another thing that like we were also researching about this randomness and all is we were researching upon something VDFs, right? Verifiable delay functions. So is it like something you are supposed to solve you can say a mathematical problem kind of a chaining system, right? One step after the other step and so on. So it is like it won't give you you can say a feasibility that you can like get a lot of computers and solve a mathematical problem altogether and solve it in a less time, right? So it's always you are supposed to do the steps in a chain to get the final result. So I guess that BDFs can be a new consideration as well, right? What do you think about that?
So verifiable delay functions, I feel bad. I don't know the answers to some of these questions. I haven't heard a lot about them. So I would have to defer that. But
yeah, completely fine. Yeah, we all are like researching over that, so it's like completely new area of research. And right, another question in my mind is like, as you pointed out in your talk about like ECC as well, right? Mostly being used and like proof of work, like most of the chains right now for signatures for cryptography and all. So but we are seeing some researchers that ECC is like maybe vulnerable or like is still right now vulnerable to certain attacks. So are we looking forward to some new algorithms for these signatures? We recently saw some new cryptographic schemes and like signature algorithms competing together, right? For NIST standards and so on, right? So, what are your views about that?
Yeah, so the question is, what's my view? Just kind of repeating for my stream as well. What's my view on, potentially replacing elliptic curves? It's, I think, a fairly important consideration for future-proofing blockchains. One of the questions people ask all the time is, what are major blockchains going to do about quantum computing, right?
Right.
Because elliptic curve algorithms like, the ECC, like the SecP256K1 curve, those are vulnerable to certain quantum algorithms that can break them in a much more feasible way than traditional computing can. So I think at some point we're going to have to replace those algorithms with something that's better. Some blockchains are experimenting with and moving towards the use of like Schnorr signatures, which my understanding is they're less vulnerable. And another fact that I find interesting is too, like with addresses, every Bitcoin address is not just a raw public key for an elliptic curve, but it's a public key hash. So we take the public key and then we run it through, for example, in Bitcoin, we run it through SHA and then we run it through RIPE MD160, which is a different hash. And so you can kind of stopgap that problem by completely avoiding address reuse. Because when you send coins, when you receive coins to your address, until you spend from that address, nobody knows your actual raw public key. So in a sense, like even if we found out a quantum computer tomorrow could break, SecP256K1, we would be able to sort of at least avoid that problems with every coin being stolen immediately, or Bitcoin just going to zero and being useless. Because we have other non-quantum vulnerable algorithms standing in the way. Like hash functions aren't affected at all.
Right.
Does that answer your question?
Yes. Yeah, it does. It does answers my question. And yes, actually, Davis has asking like, Josh, do you use a lot of academic paper or math proofs in your day job?
So, thankfully, no. I'm going to be honest. I'm not a math guy. I mean, I did, sort of the requisite math for my computer science degree. But I'm really interested in applied cryptography. So, like, I love how this stuff is applied out in the field, like in blockchains. So what I kind of like to use is I like sort of secondary sources for learning about cryptography. Like I have 2 books on my shelf over here. Practical Cryptography by Schneier and Ferguson, 2 very well-respected cryptographers, and one called Practical Cryptography,
Modern Cryptography.
I think it's either Modern Cryptography or something like that. It's by J.P. Almason is a resource that I go to, and they do a really good job of breaking down sort of the general math and the general things that you need to know about crypto algorithms. So I highly recommend checking those books out as sources if you're interested in learning about this and you're not like a super in-depth math person. Because like I said, I'm not, but you can kind of learn about the general issues, which is the idea that these problems have to be hard to solve, right? We're talking about computationally difficult problems like the discrete logarithm problem and those sorts of things that make elliptic curves, and factoring large primes, right, is what is the basis behind RSA. So there's some cool other sources out there, and thanks again, Davis, for the question. There's one other question here. I don't see a name. Can the OS's random sources like dev/u random implementations also be vulnerable to any kind of insecurities like entropy estimation, for example? At a high level, I mean, of course, they could have vulnerabilities. These systems are really, really well scrutinized. Like, for example, Fortuna superseded an older algorithm. And one of the interesting things that I read about Fortuna is it actually does away with any kind of entropy estimation as part of the algorithm. So entropy estimation, like trying to figure out if entropy, say I want 8 bits of entropy, trying to figure out if that entropy is actually random is a really, really hard problem to solve, and it's really inaccurate. So modern implementations, as far as I understand, kind of do away with that. And they're really relying on what we know mathematically about the underlying crypto functions like AES in counter mode and the environmental data that we're collecting. Another thing that I think is sort of related to this is dev/urandom will always give you random bits as much as you want. Dev/random on Linux will attempt to estimate the entropy in the pool and will block. It won't give you more bits until it thinks it's collected enough entropy to give you, say, another 256 bits. And from what I've read, cryptographers are kind of steering people away from that now because, again, entropy estimation is a really hard thing to do. One last thing to your point, because I want to make sure I answer your question, is, what kind of insecurities do you have to worry about? One of them that's a real practical thing that programmers and cryptographers talk about is if you have a really fresh system generating keys. So, for example, say you're a sysadmin and you're spinning up 5 virtual machines, and they're all going to be web servers, and they're all going to start generating their own TLS certificates. There's been research done that says even though these random functions are really good, sometimes the systems on startup don't really have enough environmental entropy, like key presses and mouse movements and those sort of things, especially for virtual machine like servers and different system activity and PIDs to feed the random thing. So that's one practical consideration that folks out there can think about is if you spin up a new system, you might want to really hammer at the keyboard for a while or something to help feed the random sources. And that's why companies like Cloudflare even do funky things like literally filming lava lamps and using the thermal noise and the unpredictability of lava lamp movement to kind of feed their sources. Oh yeah, and thank you, Dave. It's a serious cryptography. It's sitting on my table downstairs, and of course I'm forgetting the name when I'm talking to people. But, yeah, hope that answers the questions and everything. I think it's a really interesting topic.
It is, sir. It is. It is a really cool topic, and I would highly recommend, if you like a little bit of math, you should definitely be into this research because this area needs research, and this is constantly evolving. And we need new cryptography algorithms because we want to secure our schemes from quantum computers. That is the next big risk that we will be going soon to see. But yes, and thanks to Josh for putting these research together and sharing his knowledge. And thanks for the recommendation for these books. And definitely check out these books, CS Cryptography, Modern Cryptography. These are some really cool books. And yes, so what is your next research gonna be, Josh?
I just love to tinker with this stuff. I don't go even necessarily into super deep research projects. My favorite thing is just, that looks interesting. Let me read about it for a while and put out a tutorial. So,
Correct.
I love exploring this stuff, and I always appreciate the opportunity to hopefully make computer science topics like this more digestible for people that are getting into the field and just wanting to expand their knowledge. So thanks again, everyone, for checking this out. Thanks so much to the team for having me. Again, I love the work you're doing, so much appreciated.
Yeah, thanks, Josh. Thanks for that kind words. And like, we always love the support that we got from you. Like, you're always very supportive. Like, whenever we give you a text, and you're always ready to jump in. And yeah, so that is so lovely. And like, adding to it, Josh has already did like entropy session and randomness session in the DEF CON last year, right? So we will attach that as well with this presentation, so that like if you're missing any stuff, just correlate this in like being ready for new just to move.
Cool, cool. Well, have a great day, guys. Looking forward
Yeah.
to the rest of the talks.
Right. Have a great day, Josh. See ya. Bye bye. Sorry.
Yeah. Hey,
Hi,
Rohit.
Vadim. So the first talk was a banger.
Yeah,
And yeah, some very cool facts and figures from Josh.
definitely.
He's literally a very cool guy. Yeah. So coming up next, who is with us?
Yeah, coming up next in few minutes, we have Rex from
Okay.
DeFi Safety.
Mm-hmm. Yeah, so
Uh,
Rex will be giving us a new topic, you can say, a new insights in
yes.
the DeFi space, right? You want to cover something on that, Arnim?
Yeah, so he would be basically talking about the allocating scores to
Mm-hmm.
various DeFi projects. Like we
Right.
have heard about proper audits, like we have heard about okay all that security stuff, but what kind of they are doing is sort of a new thing in the ecosystem. They are just not properly there. I would not say that they're auditing, or they are just kind of running their processes on smart contracts and allocating scores out of certain numbers. Like okay, the lowest scores is you cannot just trust them, right? That's a really fishy DeFi project, and
Mm-hmm.
the highest number is like yeah, you can just trust them. So I mean, yeah, like they're breaking the traditional barrier of very runtime verification, kind of a formal verification, be it audits or all sorts of monitoring tools. I'm like, just we just thought about this and evolved around this, but what they are doing is sort of something new. So I guess that would be a very interesting thing to note and learn about from them.
Right, right. So we'll be just ready in I guess 5 minutes,
Yep.
right? So is he already with us?
Yeah, he would be joining us in short time.
Great, great. So we'll be back soon in 5 minutes.
Yeah.
Great.
Now we have
Hey,
Rex.
Arnab. So we have Rex on call.
Yep. Yep.
Okay, got it. Hey, Rex, how are
Hey,
you?
I'm doing well. How are you?
All good.
Hey, Razor.
And yes, sir. How are you? And how's the thing going there?
Good, good. It's a little late, so I'm just
No
gonna
issues.
keep
It's
it
completely
quiet.
fine. Yes,
All
I
right.
got it. Completely fine. And we already set up the stage for you. And I guess we are good to go. And the stage
yeah.
is all yours, sir.
Awesome. Now, how will I do the slides, or will you do the slides, or how does this work?
You can share your screen. There's just below your panel, there is a screen share option. Just below your window,
Mm-hmm.
there are 5 options available, right? The mic, the video for the camera, and then there's in the middle there's a share screen.
Okay. I'm just bringing the presentation up.
Got it.
Okay, can you see it? Are you still there?
Not yet.
Okay, I'm trying to come back. Okay, hold on. So yeah, all right, share screen. Okay, is that
Yes, now
working?
we can see it.
Okay, now. All right. Can you see the DeFi Safety Pres?
Yes, we can see it now.
Wonderful. Okay, thank you very much. And it's so great to be able to speak with you and to give you a little bit of a background about DeFi safety. Um, our mission is to provide accurate, unbiased, trustworthy reviews. What we're really evolving into is an independent technical risk review data source. So we don't talk too much about the financials. We don't talk about tokenomics. We focus on security through transparency and accuracy in the information they provide. So we do this through a couple of products. One, or what we started with, we started back in in the beginning of DeFi summer, so May 2020. So we've been doing this now. It's coming on 2 years, which is funny when you think about it. But our PQRs are process quality reviews. So we knew an awful lot of the auditors, and my background is on aerospace safety, aerospace software security. So what I felt was I could add a little bit of input into the whole process without going deep into the software side, because I'm not quite as good at software as the auditors, but I had an awful lot on the software security idea by looking at the software process, quality, and transparency. So we came up with PQR reviews in May 2020, and that's our main product. We've got 171 on the website on I think it's 9 chains now, and that is primarily in there. You've got equivalent scores for each protocol, and the idea there is for somebody who is not technical, he can't read audits, they don't know about it. It gives them a simple, consistent 0 to 100 score that they can look at and do an apples to apples comparison between protocols with just one number. And if they want, they can dig deeper. Our second product is what we call contract scores. Now, this is new. We've been doing it for about 4 months. And this is jumping down to the next level. So we're not looking at a protocol and all of the products sort of encompassed into one number. We are looking at each individual pool. And by pool, we mean that the smart contract address that you would interface with when you deposit to the contract using your wallet. So with each contract address, you would have one score. And our score is based on a mixture of maturity, which is how long has the contract successfully held value, plus the PQR score, plus whether or not that individual contract on that chain has been audited. So all of this is combined into a single contract score. So we've got the process quality review product, and we've got the contract scores product. And that's a little bit just sort of an introduction of what we do. So, we're trying to, in a simple way, focus on the vulnerability of the contracts and to give, as we said, clear information, because our target market are the users of DeFi. So we work towards giving them security information in a clear way that they can understand. Another thing that has been a big focus for the past while in our process, we update our process, I guess, about every 6 months. We're up to version 8 now. And one thing that we've been developing is access controls. To start with, we didn't look at it, but over time we came in because more and more smart contracts are updatable. And if you're an investor and you put money in an updatable contract and you don't understand how often they can update it, then theoretically, worst case, which we haven't seen much, but is technically possible, the developers can simply change the contract such that they can take all of their money and keep it. The worst example of this was about halfway through, I would say, very late 2020, which was Compounder.finance, which was a fork of Compound Finance that they got an awful lot of TVL. They were doing very successful, and their code was indeed a direct fork of Compound until they updated it, which allowed them to basically take away people's money. So it did happen. It did happen once. And for this reason, we're looking at protocols to be very clear to their users in language that users can understand, not software language. How updatable are the contracts? Are they updatable? Are they immutable? Is there a time lock between it? Is it on a multi-sig? Just how easy is it for the developer to change the software without without the audience being able to know the change beforehand? A time lock is extremely useful in that case. So a little bit, okay, stand by 1 second. Oh, excuse me, guys. Oh, I caught a bug at the F Denver hackathon, and that's been causing me to sneeze for the past couple of days. Okay, sorry about that. Okay, so our Pqr process, getting a little bit deeper into that. So the process is basically, we ask 28 questions looking at the public information that a protocol displays. And we look at a number of factors, and I'm going to sneeze some more. Sorry about that, guys. Please step away from your screens if you don't want to catch this. And you don't want to catch this. All right, so the Pqr process. We look at code and team, documentation, testing, security, admin controls, as I mentioned, and then oracles. So code and team, the most important thing is tell us where your contract addresses are. Early on, honestly, that wasn't in there that much, but now I would say virtually all the time people display it. So we find out where the addresses are, where the GitHub is the contract indeed being executed regularly, and is the team anon or not? Now, we totally understand why people have anon teams, and you can get a 97%, I think it is, having an anon team. So yes, you are penalized for it, but not a lot. It is nicer if you know who you're dealing with from a security point of view. But this being DeFi, us understanding all of the aspects of it, yes, it's a penalty, but it's a small one. Documentation. I mean, a lot of what we're looking at with the process quality reviews is we would like an outsider to be able to verify the operation of the code before they start executing it. So imagine somebody wants to invest into DeFi, but before they do, they want to be able to validate that the code will do what the website says. By having clearly documented and tested code, then a third-party coder, doesn't have to be an auditor, would be able to go through the code and the documentation and validate, yes, I can see how it works, I can see what the fees are, I can see the method of it, yes, it does what it says it does. And in this way, it's possible for DeFi to be more transparent, more trustworthy, to give better security than traditional finance, because everything is clearly out in the open. And of course, merely having the code in a GitHub with no documentation on how it's doing is not something that somebody can validate. However, if you've got proper documentation, then a third party can validate it. In the same reason, testing. And testing says a few things. One, it proves that you've got a dev team behind the protocol team. And with some of the smaller, quicker protocols, you get the impression that they have quickly rented dev teams, and the actual people running the protocol don't have a dev team behind them. And with this, you get people who aren't able to show that they're constantly testing their code as they make changes and as they make updates. So in the testing section, we look at, does the developer have a full test suite? Do they have instructions on how to run the test? And have they run the tests on the deployed code shown the code coverage and shown that they have a full test report. And one of our biggest bugaboos, as I said, I'm an aerospace guy. With aerospace, it is an absolute requirement that you have a detailed test report when you present a piece of software avionics, in order to prove that, yes, I've tested it, here's the test results. In DeFi, primarily, you don't end up with a test report. Sometimes they'll say, "I'll just run the tests," which is often more difficult than they say. So for deployed code, it would be immensely valuable if people did test reports, and that's one of the aspects that comes up. So then we look at security, which is the audit, if they have one, and bug bounty. So for the audit, DeFi Safety is pretty well professional audit readers. So we don't write audits, but we do read them consistently. And reading the audits, you can generally, we'll look at the complexity of the audit, when the audit was done. Was the audit done before deployment, or was it done after deployment? Especially with some lower budget protocols, you sort of can understand that they deploy quickly without being audited, and then when they're able to get an audit, either financial or just the delay that the auditor gives, then they print the audit report. Often the problem with that is if the auditor finds problems, unless they have updatable code, they aren't able to improve any of the recommendations from the auditors. So they lose points for that if if the audit is done after deployment, if the audit complexity doesn't match the code. For instance, you have a very complex DeFi protocol, a very original use, yet the audit merely looks for basic reentrancy and code. They basically run some automated tests and then they say it. You'll lose points for that, because in order to be able to properly audit something very new and very complex, you need to have really look at the financial aspects of it. And that is something that only some auditors do. So yes, we read the audit and we give a score. That's probably one of the most complex parts of our whole Pqr process, because there's so many aspects that come into it. So yeah, we're professional audit readers and we give a score for that. Next thing we do in the security aspect is bug bounty. It's a tremendous aid to security if you have a strong bug bounty. And let's face it, the purpose of a bug bounty is it's the last defense before a hack. So if a problem has been found by an attacker that, is sitting there saying, do I put the white hat on? Do I put the black hat on? If you have a big bug bounty, then he'll sit back and say, you know something, I will put the white hat on. I will disclose this because the payout is so big and it's legal. It's more worthwhile to me than actually stealing the money. And then, if you steal the money, you have to it'll be tracked and you have to get it into your hands in order to make a profit. That is tougher. It's than such that a good bug bounty, it's legal, clear money. Another thing with bug bounties, it's good to have an organization such as Immunify to work with you, because they will act as your coach in claiming the bounty, which is a huge advantage once when you're trying to do it, because negotiating with the guy on your own, the person who discloses the bug is not in the strongest of position. But because these people have already got the bug bounty organized with a third-party organization, they will be more likely to follow through on the bug bounty, which is one of the weaknesses of it. So we give points on the value of the bug bounty with respect to TVL, plus whether or not they're working with an organization such as Immunify in order to coach them. So the final aspect, then we go to admin controls, and I already spoke about that. And this is how much change can the software developers, change the software, and are they clear? In this case, first of all, a few things. One, this section is basically says upgradability is a bug. The only way to get 100% in this section is to have immutable code. If you've got immutable code, you will just coast through this section, though please clearly say that you have immutable code. By this, it is an unfair thing to assume that all they have to do is look at the code and it's obvious that it's immutable, because people such as, let's say, financial people don't understand the code, but they do express security by immutable code. They know the difference between immutable and upgradable. So if you have immutable code, just clearly say so in your documentation. It's not hard. So the final aspect, which is something that we just put in our recent improvement of the code, the 0.8, is oracles. And here we're looking for documentation on oracles, and we're looking at documentation on oracles on a couple of aspects. Is your oracle architecture flash loan protecting, if applicable? And we focus on the oracle and the oracle documentation. So just quickly, that is a sort of a detailed review of what we do with our Pqr process. And something bad has happened. Okay, hold on. That's better. So the Pqr report, we put it down in a straightforward score where you, as I said, an overall score. And for us, a pass is 70%. So what you'll see on the thing is the overall score, and then the breakdown of the individual scores in each of the 5 areas that I already discussed. And each of them have a number of questions. And then you'll get the report date, you'll get whether or not there are any security incidents. So for us, security incidents are hacks or exploits or other security incidents. So another security incident might be the front end thing that happened to Badger. A hack is where there is a definite attack by a bad actor on the code, which causes a loss of value. An exploit might be something like the compound incident where a coding error causes a loss of funds. And it wasn't really a bad actor, it was a procedural error that caused the problem. When we review, we look at these questions based on the public data. And if the data isn't there, the points aren't there, and this can result in quite low scores. And we don't pull our punches. I think the lowest score that we have is like 5%. So if you look at the PQR reports that we have, you'll see everything from the very, very high 90s. I'm not sure if we still, Balancer had 100% in our previous report, the 0.7, so that's probably still. So you go from the very, very high to the very, very low, and it really depends on the protocol. And something else, when we do this, when we do a review, the first thing that we look at is the public information. We answer the 28 questions. We put it into a report. The report has links so that you can clearly see where we got the answers for each question. And then we present this to the dev team privately. So we reach out to them via Discord. We say, we did a review. We'd like to show you the report. And we show it to them privately before we publish it. And they will either ignore it, which happens in, I would say, some cases. I wouldn't say a lot. And then it comes down to if they sit back and go, oh, no, this information is over here, we immediately correct it. If they say, oh, we want to improve that, then we will give them a chance to make improvements, but we won't delay the publishing too much. But if a team is sitting there saying, oh, okay, some things, such as documentation or testing, can take a while to implement. It's not something that will be done in a day or two. Though interestingly, access controls truly is. You can, because with access controls, we're not saying what is right or wrong. We're simply saying be clear and honest and succinct in your documentation, and you'll get as much points as you have. If you have updatable code, you can get, say, 90% if you answer all of the questions very, very clearly. So you're being transparent. It may say that all of my code is completely updatable. It's all on my private key, and there's no time lock. Then, beware when you invest in it. The code can change at any time, and you'll get no warning. But at least you're transparent and you're clearly saying that. The way you'll get a very low access controls is simply not saying anything about this. And then it's even worse. In one case, at least you're clear and honest, but there you're just obfuscating, and that's where you get the low scores. So this is how we present the scores. You'll see the version, you'll see all the chains that the protocol is on, and the security incident and such. So in the questions, we can go over if there's anything that I missed there. So let's talk about contract scores, which is the new product that we're in beta in, as I said, and we've been running this for about 3 months. So this is a much younger product, and it still has an awful lot to grow. They're designed to give investors simple technical ratings on the security and transparency of DeFi products. So by DeFi products, we mean an individual curve pool, an individual yearn pool, the address that you interface with. Now, an interesting aspect of this, if a very big protocol, all interfaces are through one proxy address, then the entire protocol gets one contract score. So Synthetics, for instance, has one contract score for the entire protocol, even though it's an immensely complex protocol. Whereas, say, Badger Finance or Curve have hundreds because every single pool has their own address and their own score. So the information that you'll see there is the name of the contract address. So, Badger WBTC, the contract address, and the contract score, which is developed by an algorithm which takes into account what I mentioned before: maturity, Pqr score, audit status, and hack status, whether or not there's been any security incidents into it, all of that into one score, which is updated daily per protocol through the maturity score. So just an example here, if you look at Aave v2, they have a 96% contract score. So they have, it's a very old contract, over a year. It's holding $1 billion, has not had a security incident in it in that entire time, in over a year. And they have a very high Pqr score, 91 out of 100. So that will give them, on mainnet, a 96%. This is a near perfect score. And, no surprise with Aave, which is as blue chip as you can get in DeFi. So another aspect that we're bringing in, and we'll be bringing in on both the PQRs and on contract scores, is penalties for security incidents or hacks. And here you can see a list of some of the hacks that have come out. So you can see the big cream hack in October, and we come down and we look at, for instance, we define them as a hack or an exploit. I define the difference. So a hack is a clear bad actor taking value out of the protocol, where an exploit is something else. So the compound was an exploit, the Badger front end thing was an exploit. And then when we look at it, we go over the reports from people like Rect and information on the Security Telegram channel and other information. And we try to find out, generally with this, you get an idea of, is this something that in an ideal world they could have seen? So if you look at, say, the compound hack or the compound incident where they had a greater than rather than a greater than an equal sign, what is the result there? Yeah, they could have seen that. So that is clearly a preventable incident, and there's a different scoring for that. Whereas if you take a look at the big cream hack, this was an original way to use a new DeFi product, and an awful lot of people were surprised by it. So this was unforeseeable, and you know, a preventable gets a bigger penalty than an unforeseeable. We also say whether it's major or minor. In this way, we're talking about if it's more than 15, if the loss is more than 15% of the TVL, and honestly, as we went through, virtually everything is a minor, because even some of these very, very big hacks end up being small as per the TVL on the point. So all of this we calculate into a penalty. We have some guidance in there using all of the aspects that I mentioned, and you get something between 5 and 25% as far as a penalty. And this is then subtracted from the PQR score. So if you have a 70% and you have a 15% penalty, then you would have a 55% as your resulting score. The other thing that we'll say is this is cumulative. So if you look at Cream with the AMP hack, which was clearly preventable because they didn't read the AMP token contract before they implemented it in the pool, thus opening an attack vector, which a little bird told me they had been told about in their audit report. So the 25% and the 15% means a 40% penalty for Cream. And we have, at least at this point, we have said that these penalties will be attributed to a protocol for 6 months. So this is an arbitrary date that we picked. After 6 months, the penalty for a security incident is forgiven. Now, one thing that I can put out that when we look at this, that I think from a security perspective is something that DeFi Safety would say rather than some of the auditors. If we look at the compound hack, and you start to see that these are things that and the Cream AMP hack, just looking at those two examples, these are security incidents that took place because they were not being careful enough with the day-to-day activities of their protocol. So in the case of Compound, they had one dev without a lot of support doing the code, the test, the deployment to the testnet, and then the presentation to the auditor. It was pretty much a one-man show. In aerospace, you wouldn't have generally the same person writing the code is writing the tests. You would have a quality person involved. And if you sit back, and especially if you look at somebody like Compound that is dealing with billions of dollars of other people's money, for them to have a team look at all code changes is not asking too much, and it will add safety. And if you look at that, I think it was he was a very good dev. He didn't do anything wrong. He was entirely capable, but it was an oversight. That happens. But if you have 3 or 4 eyes going over the process, and yes, they did have an auditor take a look at it at the end, but I think he missed it. But if you'd had people involved in the development process, multiple people, then this very much could have been something that was recognized earlier. Simply put, with DeFi, we all want to be slimmer, meaner, leaner than TradFi, and there is much to be said for that. But by the same token, when you're dealing with massive amounts of other people's money, making sure that you have enough people on looking at things is absolutely important. And when you look at the Cream hack, where it was an ERC 1155 token, the AMP token, rather than an ERC 20, and that was it's a different token. The code is quite different, and that opened up an attack vector. That was once again people not looking. So I would say, especially over the past year, the big lesson that we would put towards protocols is build up your team so that you have enough people looking at the steps that you do in the operation of your protocol to minimize mistakes. And both of these were clearly things that should have been caught before they went into production. Okay, enough on that slide. So that's pretty much the summary of what we wanted to say. We do have new products coming up. We are considering or in development of chain scores, where we will actually give scores for chains. We are looking at things like putting in an aspect of developer response time, because that's a metric that we find is indicative of a good protocol that we do have. So there's a lot that we're looking at building, and fundamentally just giving an idea. As you can probably see, what we do is built on people, experienced people looking at DeFi protocols. So we have avoided automation. Automation can give you some data, but a lot of the time, taking the time to find the data yourself tells you more about the protocol. A good example here is sorry, I lost my thought. Oh yes, looking for the contract scores. So the contract addresses should be easy to find on the website. Now, it doesn't have to be, standing out in big bright lights, because it is a developer aspect, but it shouldn't be hard to find. Our basic thing is in 2 or 3 clicks, you should clearly be able to find it. Like, say, you go to the software documentation and they have a contract scores aspect in it. You could make a bot that could find the contract scores 100% of the time, but it would be much more difficult to make a bot that looks at the labeling on the website to make sure that it's clear and findable. And that's where you need experienced eyes on it. So we truly are people analysts looking at DeFi, and we learn, we change our perspective, we change our process. And yeah, our process gets bigger over time because we should all be improving. So that's one aspect. Another aspect that I would focus on is our customers, but then we're not charging yet, but we will be charging within the next 3 to 4 months, is DeFi users. Now, I would say our aim is more for institutional DeFi users, the larger private houses, hedge funds, because they're used to paying for their data. But the important thing is we're not paid at any point by the protocols, and we want to get the money from the DeFi users so that we're clearly and consistently independent, which I suppose is the big thing that I'll leave you with. Our mantra is independent, transparent, and objective. So independent, we're not paid by the protocols, so the information is just from us to you, the DeFi user. Transparent, we expect the protocols to be transparent, but we live by example. We show our work. We show our process. If you want to ask why you got a low score, it comes down to which of the 28 questions would you like to improve on. And then the information has to be public or you don't get scored for it. And then the final thing is objective. Because we're independent, we keep ourselves objective on all of these aspects, and we try to be as fair to the DeFi protocol and to the DeFi user as we can, but with the idea of the DeFi users getting a clear idea of the security. And then the final thing, the PPS that I'll leave with, end of last year, as I said, we've been doing this. We've done, I think, 300 reviews. And right now we have 171 protocols. One, because we've retired some protocols because they're dead. And two, because we've reviewed many protocols like Curve, Compound Balancer many times because they've updated their process and we've updated their process. Anyway, so we've done a lot of reviews over a long time. So it came down, does the DeFi safety review score actually work? Does it actually reflect safer protocols? Because a cynic could say, all you guys are doing is checking if there's code in docs. You're not looking at the code, so you have no idea whether it's safe or not. However, when we looked back on a year and a half of data, what we said was, if your PQR score is over 80%, then you have about a 96% chance of not being hacked. And by not being hacked, we're basically saying from July 2020 to December 2021, which is basically forever in DeFi time, has not been hacked or had a security incident, to use the proper act. All of that to say that I think we're onto something, and the DeFi safety scores do appear to truly reflect safety in DeFi. Okay, that's me done talking. How's that?
That's so wonderful, Rex. And we are getting like a lot many cool aspects from DeFi safety and the PQRs and all. We have a bunch of questions for you to answer.
Mhm.
So just be ready. So the first
Okay.
question, yes, that I want to ask, like coming straight from me only. So it's like, yes, so just want to recap and just want to pick up a very cool point that these points, right, like DeFi safety, the PQRs, the contract scores, it's like bridging the gap of trust that is between users and, you can say, the contracts and the protocols that they try to interact with, right? Like most of the time people are not that much technical, but they want to trust the protocol, but I guess there are not enough options for anyone to get an idea whom to trust, whom to look for, right? They just have to
Mhm.
trust the you can say UI or whatever they have given us or they have said to us, right? So I very much liked two of the questions that are being asked, and one is the team itself, right? So it is like scoring the team as well, because most of the time we are ignore this aspect. We just focus on the technical side and don't really care much about whether the team is and or not, but that really matters, right? And the second I really liked is the upgradable contracts, right? uh, because we are now shifting somewhat shifting from the notion of immutability,
Mm.
which is the fundamental concept of blockchain, that you are supposed to have the immutable code. That's why we are coming onto the blockchain, right? We are shifting to the Web3 world, but that notion is being now changed to upgradable contracts. Like you have upgradable contract, you can now change the logic whenever you want, right? So I want to know, like, there are some questions. So I want to know, like, as you pointed out, that it's like the scores are being deducted as a result of hack, or like there is a penalty. So I want to know, like, will these scores can also go up after some time? If they do certain implementation, they fixes their code. Like, what is the procedure?
So 100%, we are all about improving the transparency and security of the codes. So if the protocol does the work to improve on any of the questions that are there, and they show this information publicly, pardon me, my Buffy Cron is not all gone.
That was so good.
Then we will increase the score. And with respect to the penalties, after 6 months, they're forgiven.
Got it.
And let's just say that's the number that we picked in our version 1 of the security penalties. And we'll look at that probably 4 to 6 months down the line, and just look at the results that we have, the security incidents that we've recorded, and just sort of review to say, is that fair? Should we change it?
Right, right. And another thing that you pointed, that there's like a very less automation, or we can say no automation, is like purely dependent upon the minds that you put into reading reports and things like that,
Mhm.
right? So
Yes.
I want to know, like, is it a tough task to constantly monitor like these protocols? Because they can do a change. Let's say we have given a score today, and they have made a change in the contracts the other day. So how are these things constantly monitored? Like, is it a tough task?
Well, yes, it's a tough task. We have a team of 5 reviewers right now, and we are
Mhm.
hoping to increase on that once we switch to our revenue model, which I saw was one of the questions.
Mhm.
So once we've got that, we'll be hiring more. Um, Protocols don't change their process, like go from balancer V1 to balancer V2 to V3 that often. We focus on the bigger protocols. So, I mean, if you look at RugDoc, they're looking at the things that pop up and pop down. We miss a lot of those. And if you look at the target DeFi users that we're doing, which are more the people who are looking at investing in DeFi, I would say more for the long term and more in a more sophisticated manner, they're going to be looking at the bigger protocols. Now, new, I mean, say when Ohm came up, it caused an awful lot of a bunch of information, and so that was something that we added quite quickly. We look at the new exciting protocols, but we're looking for more long lasting, and for that reason, the number of reviews that we do is not the every single protocol that ever popped up. So we're able to keep up, though definitely we do need more, and we're always looking at our process in how lean can it be, because we want to be able to go from one review to another. I mean, if you look at our Twitter, you'll see that functionally we are producing a new review each business day.
Got it, got it. So another thing that I want to know is
There
like,
was one guy in there who was asking about the process quality review
yes,
thing. So I just sort of showed the links to it.
you can share the links in the private chat, and we can
Mhm.
forward it.
Okay, so I'll do that, but I just sort of showed the process in here. So
Right,
yeah.
got it.
Okay.
Okay. Yes, another question that I have is like, uh, is DeFi safety currently monitoring only the well-known protocols, or is it like can someone launch their protocol with DeFi safety if they want to, like having a score or want to make a trustful environment, and want to showcase the score to the community, right? So can someone launch their protocol with DeFi safety as well?
I mean, we take requests,
Mm-hmm.
but we will give priority to requests to protocols that already have a reasonable amount of TVL, a reasonable
Mm-hmm.
number of users. So if you were a true startup, it would be more difficult for you to for us to review you. We don't say audit, we say review because what we do isn't audit. We would not give priority to a protocol that is just coming up.
Mm-hmm. Got it. Okay, and the last one is like uh, uh, I've already gone through the PQRs, and they are listed in a quite nice manner. Like another thing that I want to like want to look forward, like that would be another great thing. So it's like, can DeFi safety, or like is DeFi safety looking forward to a collaboration with some block explorers like Etherscan and all? Because most of the time developers just go over to these explorers, and most of the time users as well. So
Mm-hmm.
block explorers is like a very handy tool, and sometimes give us like lots of information is straightforward, right?
Mm-hmm.
Giving you the prices from integrated from Chainlink. So would it be nice if we like see in future score itself popping up on the like address?
We're not involved with Etherscan yet. We do have an API and we do have integrations. And as an example, if you look up a protocol on CoinGecko
Mhm.
and you the security tab, you'll see our scores right there. But we haven't been in conversation with Etherscan or Arbiscan or any of those yet. I think there is an area where you can put a review in manually, but we haven't been doing that as yet.
Mhm. Got it. So, okay, so those were my questions, and I guess you have already answered the questions from the viewers. There's one question, like I can see. So it's like somebody's asking, what were your thoughts? Like, how did you come up to launch something like DeFi safety? What was the motivation?
So I just came back from Eth Denver 2022, and that's my
Mm-hmm.
fourth Eth Denver.
Mm-hmm.
And I was there's a guy at Consensus called Kurt Dameron that was on a phone call with, and he said, I was like, I love Ethereum. How can I get involved? This is 2017, and he said, go to a hackathon. So when I went to the hackathon, I was talking with the people, and it's like, how can I help? How can I contribute? And they throw it right back at me saying, well, how can you help? What can you do? And it took a little while. Realized I had a friend who's still in the space, and I software quality on aircraft is an extremely mature and comprehensive process. They have a process DO 178D. It's extremely comprehensive, and it makes safe code, and they can update it and it stays safe. And there's a lot to be said for that. So what I sort of realized is, okay, this is something that I know from my work in corporate. So helping in this is going to be my way. And I started something called secureth.org, which was a it basically gave a bunch of processes and documentation on how to do a good protocol. And we had some money from the Ethereum Foundation to help out, but it really didn't go anywhere because there was no incentive for people to follow it. It was kind of, this is interesting, but it doesn't really show that much. So the crypto winter, I kind of took off, and then when COVID came around, and let's just say I suddenly had an awful lot of spare time from my regular job. I wanted to get back into DeFi, and it was just when DeFi summer was getting started. So I started in like April 2020, and I suddenly realized, and thing that I'd thought a lot was, how can I incentivize people to actually make a difference if I review them? And the solution to that, which is what we have, is name and shame. So, if you don't do the processes, you're going to have a low score. But if you do the processes, we'll increase your score without hesitation. And all of that came up to be the beginning of DeFi safety, which, as I said, we did our first reviews, I think, in May 2020.
Got it. That's a great journey that I can see.
Yeah.
Right. Yes. And we're
Where,
actually
where,
looking forward. Yep.
yeah. Oh, yeah. No, we have an awful lot of intent to grow, and I think we've got good wind behind ourselves. As I said, we want to start getting revenue, get ourselves self-standing. So yeah, I think we're going to grow, and I think we're going to be able to continue to contribute. So yeah, it's exciting times.
Yeah, for sure, and like all the best wishes from our side, and like what's an honor for us to have you with us, like for being a part of UnChained and sharing a cool new aspect that I guess will be a revolution soon. Hoping for it. Yes, because well, like a very much needed thing that I can see from my perspective, and hoping it becomes like a very acceptable soon. So all the best wishes, and yeah, once again, wants to thanks to the like whole team of DeFi Safety, and looking forward to see you soon, probably in our next event.
Excellent. No, it was. Thank you very much for allowing me to participate, and I'll keep watching for a little bit. It's kind of late here. On the presentations.
Right, for sure. And so bye bye guys. This was Rex from DeFi Safety. Had a cool new talk, and it was a great presentation. Hope you have learned a lot. And yes, just stay connected with DeFi Safety, learn about PQRs and all the information regarding your questions, like where you can see those 28 questions and all those stuff will be attached with the slides, and will be shared with you after the presentation, and probably in our Discord. So be ready for the next talk, and let's stay connected.
Cheers,
All right,
guys.
Max. Bye bye. Have a great day.
Bye.
Yeah, I guess have a great night. It's probably late for you. Yes. All right. See you, Rex.
Cheers.
Bye bye.
Bye.
So here I am. I'll jump back on screen.
Hey, Razor.
All good. So it was a wonderful session.
Yeah.
Learn some new things, some new topics,
Yeah.
and
What?
probably we'll see some DeFi goals rolling out into the market.
Yeah.
And now we
Yeah.
have Timur. Like we are pretty much excited about the new talk, and because it's a fairly new concept.
Yeah.
I'm pretty much sure that you won't have seen enough content on the internet.
Um,
I can I can say that. So it's like Rust is one thing, and talking about Rust security is comparatively new, and we all need that knowledge. And to share that with us, we have Timur. He's like he's a very cool guy. Like you must be knowing him like from the Twitter itself. He shares a bunch of cool new hacks and tips and tricks every day. And yes, he probably I still remembered he shared a like complete thread to learn about Rust, the approach where like if you are a new learner, want to like looking forward to learn Rust. I like he is the guy to look forward and to just dump your questions. So right now we have Timur from Halban Security, and like the Rust enthusiast. We will allow him to introduce himself because yes, it would be the right thing. So Timur, like the stage is all yours, and we all are very excited to get all the information from you. So stage is all yours, Timur. Just keep rocking.
Yeah, all right, all right. Thank you for having me. I'm gonna be having my morning coffee with you because it's a bit early in here. But yeah, hopefully It's going to be fun for you to watch. So let me share my screen super quickly. Okay. Yeah, just give me a second. All right. So hopefully you can see my screen, and let's get started. So the whole purpose of this talk is to show you an alternative way to get into Web3 hacking through Rust, because I haven't seen many information about this anywhere, so I guess it's gonna be super useful for you guys. And yeah, give you a small how to start guide, and give you and convey you a message that it's not super hard to get started with the Rust Web3 security. You actually don't need to know a lot of stuff to start auditing Rust-based Web3 applications. So yeah, a bit about me. I'm a senior security engineer at Halborn. I'm working primarily with Rust-based chains, auditing most of the time near and substrate-based projects. I love coding in Rust, as you might guess. I love teaching, sharing knowledge, and yeah, you can follow me on Twitter at Timur Guvanka, and you can follow Halborn at Halborn Security. So yeah, you can just check out the small agenda. We'll start about why you should be learning Rust for Web3 hacking in the first place. Then we'll move forward to more practical stuff in the way that how you should be learning this and what are the resources available. Show you some examples of chain specific and chain agnostic issues, and then I'll share my tip that I use, because in the Rust security world, you're gonna be, unless you want to super specialize in one chain, you're gonna be jumping from one chain to another. So you have to know how to pick up get the information about the chain and about the code and about the patterns that developers use in the specific chain super quickly. So I'm going to be sharing my tip with you, and at the end I'm going to share some resources. Cool. So why Rust for Web3 hacking? You probably know all of those guys, like Solana, Bad Bird is Kusama, Polkadot, Near, Terra. What do they have in common? Yeah, those are Rust-based chains, and usually applications that deploy on them are built in Rust. So, for instance, Near has smart contracts in Rust. Obviously, I mean, most of them have EVM support, but still, the native one is Rust. So, I mean, Polkadot just recently launched parachains, and Kusama also. So, I mean, amount of projects that you can hack on is growing. So, I mean, that's amazing time to get in. I mean, as I already mentioned, the growth of Rust-based chains is increasing. Also, the thing to consider, Web3 Rust security scene is not as saturated as the Solidity one. What does it mean for you? yeah, I mean, if you're a bug bounty hunter, less competition on the Rust-based project, because not many people are going to be hacking on them. So you can have more chances to getting a bug first. And since less people know Web3 Rust security, you're obviously going to be more valuable in the market, which is going to help you to land a new job if you're looking forward. And again, because of this, because Rust security is less, let's say, popular right now, you have not a lot of research has been done in many areas, so you have a lot of opportunities to do your own research, maybe come up with new attack techniques, and a lot more. So you might become a pioneer in some interesting attack scenarios. And yeah, again, many companies are looking forward to hiring Web3 Rust security professionals because of those reasons above. So it's amazing time to just get started. Or if you already know Solidity, you can just have also Rust. And if you just add Rust next to it, you're going to become even more valuable and even better security professional. So, okay, how to start learning Web3 Rust security? I mean, as you probably guessed, you have to learn Rust. I mean, fortunately, that's the reality. But don't be scared. I mean, look, you don't have to know everything. I'm gonna be telling this to you a lot during this talk. So the main part is to understand the code that you're auditing. You have to get comfortable reading Rust more than writing Rust. So in this case, I mean, first 10 chapters of the book is enough for you. Obviously, I mean, many programming tutorials, if you went over them, tell you that you should build a small project. Yeah, that's actually true. You're gonna learn a lot from it. And the one thing, if you're a security professional, I would strongly suggest you to check out Black Hat Rust. The guy made amazing book that just teaches you how to build some hacking tools using Rust. I mean, that's going to be a fun learning experience for you. Again, I mean, don't afraid to ask questions. I mean, Rust community is super welcoming from my experience. And it's okay, I mean, to struggle understanding. If you know a bit Rust, you know there's concept of ownership or borrowing. It's okay to struggle with this. And it's okay to fight the compiler all the time, because I mean, compiler in Rust is unforgiving, but it's a good thing. I mean, less runtime bugs for developers. So, and again, as I mentioned before, you don't need to know all to start building or your own application, maybe your own tools, and understanding how other applications work. So yeah, that's the basics of learning Rust. And again, I mean, learning Rust is one thing, but unfortunately, as I mentioned before, each chain is different. I mean, if you want to get into auditing chains in in Polkadot, you have to know Substrate, blockchain development framework. That's one thing. And if you want to start auditing smart contracts on Near, you have to know how smart contracts are built on Near. Even though both of them are written in Rust, they are completely different. So after learning Rust, you have to learn the basics of contract, chain development for the target that you picked. I mean, again, no need to know everything. And the easiest thing that the tip that I can give you to learn chain-specific development is to go over some basic tutorials and then read a lot of code. I'm gonna touch that thing a bit later in this presentation, but just let me give it out for you right now. So, know your chain agnostic issues. What are the chain agnostic issues? Those issues that exist in every single chain as long as they're written in Rust. And usually those are Rust security issues, because I mean, if the application is written on Rust, it's going to have integer overflows. It's going to have casting overflows. It might have stack overflows. And if application uses unsafe Rust, those guys are also going to be there. So you can just start with the Rust security, because that's a nice foundation for you to continue exploring the more chain-specific bug types. So just lay a foundation, learn the Rust security. I'm not going to be sharing resources at the end, so no worries about this, but let me just give you a quick how-to guide so that you know where to start your learning adventures. So yeah, learn Rust security. If you already know how to find integer overflows and casting overflows, you'll be able to find some bugs in real world applications written in Substrate, Near, Solana, doesn't matter. So yeah, I mean, you're already doing a great job. So know your chain agnostic issues. Access control. Access control issues exist in any chain. Again, the bug class is chain agnostic, but in every single chain, access control is obviously different. But I still put the chain agnostic issues because the bug type overall is exists in every single chain. And it's super low effort and high reward to just, when you go into like learning Near, let's say, I want to start auditing Near smart contracts. Just learn the access control rules patterns first. That's super low effort, high reward. Then you combine this with the Rust security issues. Oh, amazing! I mean, you already can find a lot of bugs, because you'll be surprised how many times I've seen people forgetting to put some ownership checks on their private functions. So that's super low effort, high reward. So I always suggest to start with access control issues when learning a new chain. This is an example of the substrate and Near access control differences. Since the first one is Near, like in the first row. So I mean, as you can see from here, we are just checking the predecessor account ID. And you can think of the solidity in solidity terms as message sender to be equal to owner. If it's not, we're gonna panic. So it's correct. I mean, it's fine. But here we forgot to put it, and now anyone can pause the smart contract. Here, equivalent example in Substrate. In Substrate, we have the origin, who is responsible for toggling a shutdown, basically like pausing a function. And here we don't have it. We only check whether the call is signed. That's all. That's all. So I mean, as you can see, I mean, it's super easy to find access control bugs in that sense. And if you already know how to find those, plus, as I mentioned before, knowing some Rust security issues, you already in an amazing place. Another one, logical bugs. Any software has logical bugs, and if you read enough Rust, and as long as you can read Rust, you can find a chain-specific logical bugs. I mean, easily, as long as you understand the application, logical bugs are gonna pop out. So it's as easy to find logical bugs as long as you understand the application, obviously. And to get better at understanding application, you have to get more comfortable reading Rust and reading the chain-specific code. And about that, and about the way you should be learning it is later on. So yeah, again, congratulations. You already know more about Rust, Web3 security than the most people can. At this point, you know Rust. I'm assuming, like, just imagine at this point, you learned Rust security, just the Rust security issues, the basic ones, like integer overflows, casting overflows, etc. Then you already know how to find access control bugs in your chain. And plus, you're comfortable reading and understanding the code, so you can find the logical bugs. So amazing, you're already doing a great job. And then afterwards, if we move to more chain-specific issues, if you learn those, you're gonna be even better. The whole message I'm trying to convey here is it's not super hard to get started. So just start with Rust security, learn access control bug, get used to reading Rust code to find logical bugs, and now you're already doing a great job, as I mentioned before. So get to know your chain-specific issues. These are types of vulnerabilities that exist only in a certain chain. So I mean, that chain-specific issue exists, let's say, only in Substrate, but doesn't exist in Near. So that's an example. And yeah, as I mentioned before, then there are not many research that have been done. There are not as many Rust Web 3 security folks out there, so you have opportunity to invent new chain-specific bugs and attack scenarios, attack vectors. Like if you decide to concentrate on Substrate, you might invent some new stuff there, or Near, you might invent some new stuff there. So it's an amazing place to be in. And here is an example of the chain-specific vulnerability for Substrate. Verify first, write last. The basic example that in Substrate, you are not building smart contracts, you're building chains. And the state in Substrate is not cached. And there are no like reverts in errors like by default. So what it means for you, you have to verify the data that you're writing first. So for instance, let me just give you an example. Here you just like simple example, we applying for something and we are sending our application, and there is like a minimum application deposit. So if you check the code, if you're coming from smart contract background, let's say, you're reading this code and like, okay, we're searching to a storage like the sender and some application struct with some data. And then we're ensuring that deposit is bigger or equal to minimum application deposit. If it's not, we're throwing an error and then sending an event. Unfortunately, if you put like, let's say you put a low deposit in here, you will trigger this error. For sure, you'll trigger this error. But unfortunately, since since you're already written into a storage in here, your deposit, even if you trigger an error in here, you'll still have this thing in the storage that can be used later on. That's super bad. I mean, that's why you have to always verify first, which means putting that ensure statement before you inserting or removing or mutating a storage right here. So yeah, that's one chain-specific bug in Substrate. I mean, and it doesn't exist in Near, for instance. And yeah, the tip that I was mentioning before, and it's key. It was actually key for me. I hope you'll also find it useful to learn a new language or new chain, because if you're passionate about like a Rust security and Rust-based chains, you want to try many different things, and because of this, you have to learn how to pick up how to get comfortable reading the code and understanding the code quickly. So that was the thing that helped me. I mean, surveying technique. What it means is you have to basically get exposed to large volumes of the code on a daily basis, or at least, I mean, as I mentioned there, like 3 times a week. Basically reading a lot of code. I mean, it doesn't matter. You don't need to go super deep inside. Just, for instance, you picked Near. You went over the basic, let's say, development, like a couple of tutorials. Then, while working on your, like, let's say, Rust security issues, just go every single day. Just pick a project that you like and skim through its code. That's all. I mean, just skim through its code, then go to another project, just skim through its code. You don't need to go deep. You just want to read as much code as possible to catch patterns. That's what you need to do. Like, as you can see, like, the benefits of surveying. You want to, when you're reading a lot of code, you will recognize some patterns. You will see that many developers doing similar things. They're using similar access control patterns. And if you encounter something that is off, you'll be able to quickly recognize it and be like, I've seen this before. It looks incorrect. Let me go deeper into this. So it's super quickly, and it's going to help you navigate the new code base quicker, and also will get used to reading a lot of Rust code, which will help you to audit stuff quicker and understand what a certain function does. You may also encounter some new syntax, new patterns, new APIs from the SDK that certain project uses that you haven't seen before, which will increase your overall knowledge. So yeah, those are the resources that I compiled for you. There is like Black Hat Trust that I mentioned before. I'm pretty sure you'll like it. I have a feeling about this. The guy just built a lot of cool hacking stuff, hacking tools with Rust. So you can just read through it and build it at your own pace. And I'm pretty sure it's going to be a fun experience for you. Fuzzing Labs is another one. They have an amazing tutorial for Rust auditing and fuzzing. If you're interested in those, I'm strongly suggesting you to check it out. Quality is amazing. I really liked taking their course. And this one, it's just my thread on Twitter. You can just go over it. I also shared some resources in there also. And let's get Rust UNL. Basically, the guy has a playlist of the Rust book. First, I can't remember, 10 chapters or so in the video format. If you like watching video more, just check this Let's Get Rust YouTube channel. And the next channel is more, let's say, for more advanced Rust people. The guy has like a 2-hour, 4-hour streams where he dives deep into one specific topic, for instance, Rust macros or some pointers, and so on and so forth. So if you reach certain level of Rust knowledge, I'm strongly suggesting you to check this YouTube channel out to learn more about specific topics that you find interesting. I mean, the Rust book, everyone knows Rust book who's in Rust community. Just the standard, the first thing that usually everyone tells you to take. Rustonomicon. If you don't know, in Rust there is like a safe Rust and unsafe Rust. Unsafe Rust basically tells the compiler, no worries about this specific code. Developer knows what he's doing. Developer knows what the code does, and he knows that there won't be any issues. But usually it's not the case. So Rustonomicon goes over all the Rust, unsafe Rust patterns and ways how to write them correctly to avoid some Rust issues that I mentioned before, like double free, use after free, etc. And the secure Rust guidelines, again, as you may guess from the title, those are secure Rust guidelines. How to handle errors, how to manage crate, and yeah, that's it about the resources in here. So yeah, that was a quick overview of everything I want to cover in this talk. It was high level because there are not many resources out there, and I wanted to first give you a high level overview of everything that I think are going to be beneficial for your journey, and hopefully in the next conferences, if I join, I'll go deep into some of the topics. So yeah, do you have any questions? Let me stop the screen sharing.
Hey, Timur, we got some queries from the community. So the first query is: are there any chain-related libraries, standards out there to take a look? Maybe be it a Web3 REST frameworks, like a Solid
Uh,
PK kind of thing. Yeah.
Standards out there. I mean, for near, yes. For instance, I'm just gonna talk from the from near. There's like a near Rust SDK that people use to develop near smart contracts, and there are also some near standards. I'll share the link afterwards in the chat if I find it. But they have like a already, like, if you think about the ERC20 or any other standards, those guys also build those, so you
Mhm.
can directly read through their code and understand how the standard stuff is built. So, for instance, for Near, there is a similar thing. Actually, and for Substrate also, there is like a open runtime module library, which also built a lot of like a standard stuff in a secure manner. So I'll share all the resources in the whatever you tell me. So
Yeah, I mean, you can just drop in the private chat, and we would just share with the community.
yeah, sure. Just give me for
Uh,
ML.
Coming to the next,
Uh,
yeah, okay. Mm,
just do this. Yeah, here we go. Okay, where can I pay? Okay, I shared with you, and this one near smart contract standard, and this one.
yeah, cool. So, I mean, we got another question. So in the for Rust smart contracts, is there a way to disassemble compiled code, like disassemble bytecode to opcodes for Ethereum virtual machine?
Um, yes, I mean you can look when the Rust code, for instance, for smart contracts are compiled. They're usually compiled in the WASP format, in the WebAssembly format. Obviously, you can reverse engineer it back, decompile, but there is no way to, like, in many cases there is no ABI available, so it's hard to get the actual code back. So that's the quick answer.
Okay, like Davis says, fuzzing lab seems costly.
Yes, I mean, yes, it is. But if you have, let's say, you obviously, I mean, if it's costly, but if you have some additional money to spare, I'll strongly suggest you to take this. But free resources are also available out there. I share the basic Rust security issues out there. You can literally just Google them, every single one, and you'll find some resources out there about every single one of them, like a Google integer overflows in Rust. You'll find some articles about how to find them, how to exploit them. So, but Fuzzing Labs provides you a more structured way, as any course would do.
Yeah, and we GN says thank you, Timur. It was a fantastic talk.
Oh, thank you very much. I really like being here.
So I guess we don't have any more questions from the community as of now. And guys, I mean, if you whenever you have any queries, just feel free to uh, drop in the Discord server. We have every speaker out there. And okay, Drazer would like to ask you a question. Please, Drazer.
Yeah, Timur. So yeah, it was really wonderful. Yeah, I'm just making my notes of like which thing to go for next, right? But yeah, it was amazing, and I just want to know, like, are there any kind of let's say CDFs available, or some challenges for everyone to play, or like practice their
Hmm.
knowledge, something like that?
CTFs. Haven't seen any, to be honest.
Mm-hmm.
I mean, we have. I mean, Max. No, haven't seen any, to be honest. Actually, that might be an opportunity for all of you guys to learn and build some cool CTFs. I mean, why
Right.
not?
Yes, we really want that, right? So everyone just watching this, just uh, take some motivation. Go ahead and let's build that, right? Let's have some CDFs. because
Yeah. I mean,
yeah,
there is no like a Ethereum or something like that in the like a standard thing that everyone knows about in the Rust community. So
right.
you might
But
just start with
yes,
this.
there were a lot many resources which were shared, and I hope everyone had made their notes. But all of these slides and the resources attached to it will be shared in the community itself, so you can definitely go ahead, rewatch this video, the presentation, and correlate the information that you want to learn, and just keep rocking and get into the rust and just be rusty. Right.
Yeah, definitely.
Right. So yeah, once again, thank you so much, Timur, for like I know it's super early for you and taking out some time. And yeah, I know it's Sunday for you. You're supposed to sleep a bit longer. But
No
yeah,
worries, no worries, no worries. It was worth it. I liked it very much. So
thank you so much. And once again, obviously, you are like doing it on a daily basis. You're sharing your stuff, but still, we are looking forward to see you soon. Way soon, maybe in our next event or so. But yes, thank you so much for sharing the information and all. And have a great day. I guess. Are you going to sleep again?
no. I definitely won't be sleeping tonight. So
All right. So, yep. Looking forward to see you soon. And have a great day, sir. Bye bye.
have a nice one. Bye bye.
Bye bye. All right. So I guess if we have like little bit time
Yeah.
for like to have our next speaker. So I hope everyone is pretty excited about our next speaker. Uh, like I guess we all know about him as like whenever we get some notifications that Mudit has okay, I'm not on camera. Okay, yes. So it's like whenever Mudit posts something on Twitter, it's like, oh, okay, yeah, something happened. Yeah, something happened, or something is about to happen. Yes, and we are supposed to just keep our fingers on, fingers crossed, like it should not be critical at least. Yes, but yes. So we will be having Mudit Gupta soon onto our stream, and he will be talking over security trilemma. Like it will be interesting. We don't know much about this because yes, a kind of a surprise for you. So hoping for everyone to learn cool new aspects, cool new things. So stay connected, everyone, and we'll see you other side of a little break, we can say. So
Yep.
stay connected, guys, and we'll see you soon. Bye bye.
Yeah, and guys, it's a quick reminder, like, do join our Discord server. Like, we have seen a lot of people
Right.
asking
Let
about
me
the.
share that as well. Let me just quickly
Yeah.
share that.
So, like, the presentation decks would be shared in our Discord server real soon after the event. So, just make sure you guys join the server and stay updated with the latest events.
Right. Let me just quickly do that. And there you go. Got that. Right. Awesome. And we'll be back soon in just a couple of minutes after a quick break. So stay connected, guys, and uh, maybe have your breakfast, take some coffee shots, and yep, be right back.
Hey Razor, I think it's time to start with our next speaker, right?
Hey, Arnim. Yes, I guess we all are ready. And I guess we have with us one of the coolest security
Yeah.
researcher in the Ethereum and substrate space. Hi, Mudit. How are you?
Hey guys, I'm good. Thanks for having me.
So glad to have you with us. Like, it's an absolute pleasure and honor. And yes, we all are pretty much excited, and the community is like looking forward for your talk. And yes, we already have like lots of questions that we have received from the internal team. Like, many people are seeking for your advices, like your approach, like how you tackle different stuff. So yes, we all are like ready, and the stage is all yours. And yep.
Thanks a lot. First of all, pleasure to be here. The main topic I'm going to talk about today is the security trilemma. I'll get started once I figure out how to share my screen. Give me 1 second.
It's just below your window panel.
Yep,
Yes.
people should be able to see the slides.
Right. Yes,
Nice.
it's perfectly visible.
Okay, so the security trilemma. What do I mean by this? The security trilemma, I've defined it as a connection between or a relationship between the usefulness of a product, the funds you spend on securing it, and the risks that you carry by releasing that product. So there's a tight coupling. We'll get into detail in a bit, but before that, let's talk a bit about me. So, for those who don't know or don't know me or know very little, I started out as a cybersecurity guy about a decade ago, just a little over a decade ago. I got into blockchains via Monero. In fact, Cryptonote, which was the underlying protocol behind Monero. I started working on Cryptonote in about 2013, and from there, like I really came for privacy, but stayed for blockchains. I've worked on Bitcoin, Ethereum, Polkadot, and a bunch other chains since. I was mostly doing research work on proof of stake and blockchain applications from like 2014 to 17. And when the bull cycle started in 2017 and the demand for developers shot up, I transitioned more into a developer role. I've worked on multiple DeFi projects like GovBlocks, Nexus Mutual. I've led development at projects like Polymath, more recently SushiSwap. And now I'm advising multiple companies like SushiSwap, Polygon, Satora, and a few others. And that's like my brief journey. So I've always been uh, inclined towards security, and with the expertise that I gained in blockchain over time, that presents a good combination. Okay, moving on. So let's start with the basic definition of the security trilemma. It revolves around three aspects: usefulness of anything. Let's talk about any product, the usefulness of that product, the cost of securing that product, or like how much you spend on. In case of smart contracts, the cost would involve audits, the cost would involve development time spent on testing and quality assurance and stuff like that. And the risk is basically uh, the chance that something goes wrong. You have to analyze both the chance and the impact. So the risk is combination of both. If something goes wrong, then what would be the impact of it? In most cases, something will go wrong. So can you bear the impact of that or not? That is risk. So let's understand the problem and the relationship between this trilemma. So first of all, what do I mean by usefulness? Usefulness is basically a combination of features and ease of use of a product. So like from ease of use, I mean, uh, the simpler you make the product to use, the less barricades you add for the users. It's very likely that it easier it would be to be manipulated and to be exploited. uh, Easier things, make the best way or the easiest way to make things easy is to remove security features. So stuff like captchas that are a pain in the ass for most people. So someone might just go ahead and remove captchas from their product to increase its usefulness. but that would open the product up to botting and automated attacks. So that increases your risk. Stuff like confirmation from the user. So in terms of blockchains, if you have ever used MetaMask or any wallet, you have to click accept or confirm whenever you are signing a transaction. So that is a security necessity. User experience would probably get better if you don't have to press the accept button or change gas or look at anything. You just click on ape and you ape. But that obviously increases your risk and increases the chances people would get fooled. So yeah, basically in most scenarios, if you try to increase ease of use, you have to be careful that you don't decrease the security of the product. And then features. So features basically increase attack surface of the product. The more features your product has, the more attack surface it would have. So if we talk about a mobile phone, if you enable internet connection on your mobile phone, you suddenly open up to a new category of attacks where like anyone from anywhere in the world can potentially get access to the device and do potentially harmful things. So that is something you have to be careful about. But as you know, like having internet on mobiles is sort of a mandatory thing these days. You can't really live without it. So you have to at the end of the day find a good balance between features and security. If you remove all the features, sure, you might get a super secure product, but it would be completely useless. Imagine a phone that you can't use to browse internet, that you can't use to share SMS, a phone that you can't use to make calls. It would really be a useless product. Sure, it would be very secure. Nobody would be able to hack into it. But what are you gonna do with a brick of a phone? So yeah, that is about usefulness. And then about cost. So uh, the more features you add, the higher it will cost to achieve a baseline security. So if my goal is to do the sort of like a baseline security thing, that is like let's say I comply with all of these standards and stuff, then it would get more and more expensive to do the like compliance if you keep adding features. Doing compliance for one feature is easy, but doing compliance for 100 features definitely costs a lot more resources, both in terms of monetary and time. So there is always that cost thing you need to balance. And the other thing about cost is often tied to your overall budget. So if you spend 10% of your budget on security, you'll have 90% left for other things. But if you spend 90% of your budget on security, you'll only have 10% for developing the actual product, marketing, and stuff like that. And even though you might have a fully secure product, nobody will ever get to use it, and nobody will ever realize that exists. So you need to find that right balance in the cost as well. And the last thing, obviously, is risk. So, risk management is a complete, whole new different topic in its own. I can go on talk about it for days and days, but that's one of the like most critical bits in this space, or anyway, to be honest. Risk management entails two main things. One is finding out all of the like potential risks that are in this system. So finding out all the things that can go wrong, finding out the chances that they go wrong, and then figuring out the impact if they go wrong. So you have to basically balance these two things, that like chances of something going wrong and impact if it goes wrong. So let's say if there is a minor bug which is very likely to be exploited, but the impact is very little. So the bug might be like, instead of hi, the software might greet someone with hello. Sure, it might not be the intended feature, but the impact is very low. Difference between hi and hello is not that much. So this is a risk most products can live with without needing to mitigate it. So like this is one risk management strategy. And then there can be risk that you can't really live with or you don't really want to live with. So in a blockchain product, there is always a risk that the let's say it's a DeFi protocol where people deposit their money and it earns yields. The risk there is that the protocol gets hacked and all of the underlying that is deposited in the protocol gets drained. This way, the protocol would lose all of the liquidity or all of the total value it had logged in its system, and this would be a very critical impact. It would be very hard for the product to survive after this. So this is one risk you can't just live with. You need to try and mitigate it to your best abilities. And risk mitigation is the second bit of risk management. First is like realizing the risk, and second is mitigating them. So how do you mitigate risks? You There are multiple ways. One is you try to make the attack vector or risk less likely to happen. Ideally, it would be impossible to execute, but the lower you can make its chances to trigger, the better. The second would be to try and reduce the impact. So even if something goes wrong, you have a fallback solution, or you have some protection that the impact is low. So one way to reduce impact in such a DeFi protocol would be to buy insurance. Even if the protocol gets hacked, you can get a reimbursement from an insurance in this case. So although it would be bad for the protocol, the impact would still be limited. You won't lose a lot of money. So these are like some basic ways to do risk management. And this is basically the trilemma: usefulness, risk, and cost. You need to find the right balance between this. One like quirk or important things to realize about trilemmas and things like these is you can't solve the trilemma, you can only optimize it. You'll see a lot of marketing material stating Dash has solved the Dash trilemma, and something along those lines, changing the future and stuff like that. That's all just marketing material, that's all bullshit. It doesn't make any sense. And the basic reasoning is all of these three things that I described, and all of the three things in most trilemmas, are measured on a scale. They are not a checkbox that you can just check and say I've solved this. So like usefulness of a product, it's not a checkbox. You can't say this product is useful or this product is not useful. iPhone 1 was useful and iPhone 13 is useful, but the usefulness of iPhone 1 to 13 has definitely increased, although maybe not by that much, but it has increased a little. So yeah, it's always a scale. And also with the other aspects, the cost is not a check mark. You can't say like uh, you don't do zero cost and then one cost as a check mark or something like that. It's always a scale. You're spending 10% of your budget or 15% or 20% on security. So it's a scale of things. And same with risk. There is nothing which is absolutely secure, risk free. Even if you use a brick as your phone, there is a risk that someone would just take that brick and shove it on your head or something like that. So there is always risk with whatever you do. So there is no checkbox that you can just tick off in risk management. It's a scale. Some things are very risky, some things are relatively secure. In the blockchain world, you need to optimize for these things. So it's always like a relationship. You need to find a right balance between. You can't just check mark all of the boxes and say you have solved the trilemma. You can only optimize towards a good balance. And that's basically the main idea. So coming back to this line, you can't solve it because it's not a checkbox. You can only scale different things. You can only optimize it. So now you know why you can't solve it. Let's learn about how you can optimize it. So there are basically like three things when it that comes to my mind when we talk about optimizing any trilemma. One is extremes are bad. In most cases, you do not want to reach an extreme. That is, you don't want to be in a situation when your product is completely useless, but it's very secure and has no risk. Uh, your product won't work. There won't be any market adoption. There won't be any product market fit. It will just die. So you don't want extremes. Other examples also include like if you make your product very useful but spend 0 seconds on security, it would definitely come bite you back. Sure, people might love the product in the early days, but something will go wrong, and something will definitely go wrong in a bad way, which would be the end of your product. An example here could be the DAO hack, which happened a few years ago. So there, although the DAO wasn't built on completely usefulness, they did spend a lot of time on security as well. But that's a good example of how one mistake can really like kill the whole product. Once the DAO went down, really there was no coming back. The second point, now that you are not targeting extremes, the thing you need to figure out is to find the right balance. And there is no single right balance for all products. There are different levels of balances or different types of balances. So in context of blockchains, uh, a layer zero blockchain or a blockchain itself like Ethereum need to focus more on security than it needs to focus on features it provides. Same goes with Bitcoin. You will see Bitcoin is an even like better or bigger example in terms of finding a security focused balance. There is not much you can do with Bitcoin, but what you can do can be definitely very secure. Arguably, Bitcoin is more secure than Ethereum at the moment, and they have found the balance there for their particular product. They want to really focus on security while keeping it useful. You can at least transfer money on Bitcoin. It's not like all of your tokens are locked, so it's not a useless product. There is some use case, but they are focused more on security than other products. If we keep walking in this direction, Ethereum uh, trades off some of its security aspects. It adds more features. By adding more features, it adds more attack surface to the protocol. It adds more things that can go wrong, which implies the security is lower, overall lower than Bitcoin. But it's still very, very, very secure, and it's a very good balance for the product that Ethereum is trying to build. Something which is generic enough for other people to build on top of it while remaining fairly secure that you can actually trust it. Then after Ethereum, the scaling solutions like ZK rollups and stuff, they take this to another level where they add more features in terms of rollups and zero knowledge proofs and stuff like that. So these are more useful than Ethereum in general, but these also have a much bigger attack surface than Ethereum. Many more things that can go wrong. They have a good use case in terms of smaller plays in retail, but at this moment, due to the risk profile, you won't really see institutions adopting the zero knowledge rollups right away. The future is definitely with the rollups. I feel like the technology will mature over time, the risk will reduce, and a wider adoption will be gained. But at the moment, the risk just doesn't justify the features for the institutes. So, yeah, you need to find your right balance. And the third important thing is adapting over time. So if you find the correct balance on day zero, does not mean that you will have to maintain the same balance throughout the life cycle of your product. The market conditions change, the requirements of the users change, the regulatory situation changes, the in advancements in like crypto technologies increase, and all of these adapt your balance. So you will have to reanalyze how you are spending your resources, how you are dividing your costs over time. Maybe like for most products, they spend a lot of time on usefulness in the early days, not as much on security, and they slowly increase their security budget over time and reduce the like feature budget in some sense, because once the product is already out, uh, maintaining the product or project is a bigger task than adding new features. This is why you will see Bitcoin is more or less the same as it was in 2008. Sure, it has scaled a bit more. It does support a few new features, but it's not like vastly different. If Satoshi comes back today, he would be immediately able to realize what all is happening in Bitcoin. There hasn't much changed at the ground level. So, yeah, as Thanos said, perfectly balanced as all things should be. So yeah, you need to balance everything to optimize the trilemma. And that's basically like all of the material I had. uh, we have a lot of time right now, so I can take on questions about this or any other topic you want to talk about. uh, and yeah, I'll open it up to the audience.
All right. Yes. So it was wonderful, and yes, the trilemma is pretty much right there in the
Okay,
ecosystem.
doesn't seem like we have. Okay, sure, Madhvan, shoot your question.
Okay, Madhavan is writing, probably writing his question. So I
Okay, I'll
have one
give a
question.
minute more for
Yes,
questions.
Modit is right there.
Yeah. For audits right now, you're right. Both the cost and wait lists are quite long. That's basically like free market for you. When the demand is high and the supply is low, the prices increase, the wait list increases. So that's a tricky situation. In terms of prices, very absurd pricing is going on right now. The top tier auditors are charging from 40,000 to $80,000 per engineering week, which is, yeah, definitely super high. But you can definitely get a little more affordable audits with independent auditors or uh, smaller auditing companies. I think QuillAudits does them as well. So yep. Okay, in terms of multi-chain security, yeah, so multi-chain products right now are quite focused on usefulness, not very focused on the security aspects. As I said, they are just going through the cycle of launching a product that has high usability in the start, and they'll start focusing on security as they gain adoption. Because launching a product with high usability with but low security gives you the market validation that the product is actually going to work. If you get that product validation, market validation, then you can spend more on security. So you will see over time, definitely these multi-chain bridges and all would focus a lot more on the security bits. And yeah, in the future, to be honest, there it's a multi-chain future for sure. But as Vitalik said, it may not really be a big cross-chain future. Cross-chain messaging might be limited to bridging in the near-term future, at least. Uh, but yeah, like overall, this balance would shift towards security. And how can we combat the high audit costs? That's a good question. There is no real solution to this, unfortunately. It's a shortage of talent. The way we can solve this is by getting more talent into the space. The more people who can do audits, the cheaper it would get. Again, it's really about supply versus demand. If we can increase the supply, then things will get better. Okay, so about decentralized audit marketplaces, I'll add one comments with security slash audits. One problem is that they are very, very, very trust dependent. That implies if you give out your project for an audit to someone and they come back and tell you, hey, your project is secure, we didn't find any bugs in it, there is no way for you to verify if they actually even looked at the product or protocol, or they are just like saying this to get paid. So that's why whenever you go out for security consultancy slash audits, it's advisable to go some with someone you trust, who has market reputation, rather than going with someone from a decentralized marketplace who you don't know anything about, because then you just won't get that peace of mind in the back of your head. What do you think of Cosmos security? So Cosmos is an interesting aspect. To be honest, all of the blockchains, major blockchains, are slowly moving towards that model. Polkadot has that same model of like hub and spoke. The Polkadot chain itself acts as a centralized thing between various parachains. Ethereum is sort of also moving towards that model, not exactly the same, but once sharding lands, the goal really would be to have multiple chains which sort of acts as silos or shards and can communicate between each other. So yeah, overall, I do think it's a good model. It time will tell like if it really picks on or not. But yeah, overall, it does seem like a good scalable model.
Okay, I have one question, but so referring to the security trilemma that you pointed right in your talk. So I want to know.
Okay, I think that's it from my side. Hey, Razor folks, are there any other questions? I can't hear you. I can give me one sec. My headphone might be off. Yeah, you're audible now. So my
All right.
headphone just turned
Yeah,
off.
yeah, no issues, completely fine. Yes, so I was asking about sorry, the security trilemma, right, that you pointed out. So I want to know what is your experience and observation about this trilemma. Is it like the ecosystem is leaning more towards security or like usefulness, or is it like everything is like at the risky point right now and everyone is just trying stuff?
Yes, so there are protocols, different protocols that prefer different balance of things. So even if you look at the space, if we talk about, let's say, Maker and similar protocols, so MakerDAO, which has its own stablecoin, which is over collateralized, Maker prefers security slash safety over other things a lot more. So you'll see Maker won't be adding very risky assets to its basket, and their first aim is to keep the die pegged and secure. But you can also see that the market there is demand for a product in the market which uh, optimizes the trilemma more towards usefulness than safety, and that's where like Abracadabra comes in. It still focuses on security, but Abracadabra focuses a little more on usefulness. You will find multiple different types of collateral being supported in Abracadabra, which do increase its attack surface, but they make the protocol more useful. And you can see both MakerDAO and Abracadabra have a good like market base or user base, which implies there is demand for different protocols that optimize this trilemma differently, uh, just because that's how the users perceive it. Institutional users would likely prefer something like MakerDAO, which focuses more on safety, and retail users will likely prefer something like Abracadabra, which can get them more returns, more money.
Got it, got it. Yes. So there's one more question that we have received internally, but I guess it's a very wide question, but still, like I'm just shooting it up. So somebody asked, like, what is your approach of defining an attack surface? Like, how do you like define like there's a protocol and you are supposed to do a research on that or like find some bugs. What is your approach on defining the attack surface basically?
Yeah, definitely. So, attack surface is basically things that can go wrong. So, when I am looking at the protocol, when I am auditing a protocol and I have to like figure out the attack surface for myself, there are two paths I take. One is just looking at the use case of the protocol, like looking at what the protocol is trying to do and figuring out what can go wrong in that, and like what can be exploited. This is without looking at the code base at all, just thinking from a more like feature point of view. So if the protocol is offering one feature, the attack surface there can be that the feature doesn't work or it backfires or something like that. So I'll create a list with that, and then I'll actually start looking into the code, and from code I'll figure out what attack surfaces can happen. So this would be like white box testing, while the product thingy is more black box. So when I'm looking at the code base, I look at different types of functions, what they're doing. So if there is a function that makes an external call, that means there is an attack surface, which is you are passing the context of the call from your contract to a different contract, and then the contract can do anything after that. It can re-enter, it can transfer some tokens, it can do anything basically. So that becomes one attack surface. And I look at different code, like different pieces of code, and all of the code will basically be opening up a new attack surface in one way or another. So you have to keep track of all of these things.
Got it, got it. So yeah, that was wonderful advice, and yes, I hope like everyone would have got some approach, and there must be like if there's someone trying to learn and get into Web3 security, definitely there are some cool new advices and follow ups and startups for you to just quickly get ahead. And other thing that I want to know, just the perspective, like as we have seen, lots of drama that has happened on the Solana ecosystem, right? So, what are your views on that? And what do you think, like how they are approaching this security right now? Because we have like from the Twitter as well, we have received many tweets from their own developers, like what things they are trying to improve, what things they are working on right now. So, what is your view, and what do you think? What would be the new vision for Solana?
Yeah, sure. So with Solana, they are definitely geared towards more on the usefulness side than the security side. The thing is, like, the Solana ecosystem is quite new and immature at the moment. It's more like how Ethereum was in 2015. The only good thing that was going for Ethereum is, um, at that moment, only the experienced folks were building on Ethereum slash using Ethereum. While with Solana, now since the hype is so high, a lot of different type of people are building on Solana. People who don't really understand what they are doing, people who don't care about security and stuff like that. So although the blockchain's balance is similar to what Ethereum has, but people who are building on that blockchain are more focused on usefulness than security, by a long shot, in my opinion. Most of the teams I've talked to on the Solana ecosystem, barring a few top teams, most of the teams on Solana are completely focused on usefulness than security. One main reason for that is there really isn't much resource out there to learn about Solana security right now, and there are very, very, very few auditors who actually audit Solana contracts or Solana apps. The talent supply is even shorter in the Solana ecosystem. So people are just like uh, launching their products and praying for the best, which implies there definitely are more uh, hacks or like more risk in the Solana ecosystem.
Right, that is absolutely true. It's like uh, not much information available. People are actually interested and looking forward to Rust and all, but yes, a little less. We can say developer ecosystem. Like less protocols are there and less. I would say less information available, less blogs for everyone to read, so stuff like that. But yes, people are interested. We have one more question from Jagdish. He's asking like, I see a lot of bug bounties in Immunify ranging to $10 million. So, what is the advice for people who want to enter this space to help find the bugs or help secure the protocol?
Yeah, definitely. So, if you're just entering the space, I would really recommend that you learn about blockchains first. Then you start learning Solidity a little, and then you start thinking about security. When you come to security bit, I highly recommend playing all of these different capture the flag events. So, Ethernaut, Damn Vulnerable DeFi, and there are a few others. who basically have who give you challenges which you need to exploit slash hack to move to the next level. And that way you would be able to learn about all of the common mistakes that different teams make, common pitfalls in solidity, common attack vectors, and stuff like that. Once you understand the basics, then you should start looking at these bug bounties. I would recommend starting with protocols that are new, rather than protocols who are old and now offering 10 million in bug bounty. So I think MakerDAO is offering that. I might be wrong, but starting out with MakerDAO can be, obviously it's a very high reward, high risk situation there. But I wouldn't recommend new people to start finding bugs on MakerDAO, because it would be hard to find anything there. And if you spend like multiple days, multiple weeks on an app and then don't find anything, it can be a little disheartening. So for newer people, I recommend that you start with newer applications. Apart from Immunify, also look at Code Arena. It's much easier to find issues in Code Arena projects because those are like unaudited projects. Sure, the rewards are much lower than bug bounties at Immunify, but at least for someone who is starting out, I feel like that morale boost that comes from finding something is more valuable than just going for the top money.
Right, absolutely. Uh, Arvind, can you just share the Code Arena link in the chat so everyone can just look around? All right. So yes, that was great. Yeah. Other question that I have, I guess we have some more time. I know, it's been pretty late for you, but yes. Okay. Just some more questions. Is like, talking about Ethereum itself, right? So as we know that Ethereum is kind of like trying to shift from ETH 1 to ETH 2. There will be new sharding and all chains going on. So, but the one thing that I've been following along for a very long time, the core team, there's one challenge there they are trying to solve, is the scalability. So they have been trying multiple solutions like statelessness and all, stateless clients. So what do you think about that? Like, because we know scalability is a problem with Ethereum. So what is your perspective on that?
Yeah, definitely. So, the latest merge that is going to happen in about 3 to 6 months from now, which is technically ETH 2, but we call it proof of stake Ethereum now. ETH 2 no longer exists. So, that change will move Ethereum from proof of work to proof of stake, but it won't do anything for scalability. Scalability will come with sharding. That will happen in about 2 to 3 years is my best guess. There is no fixed timeline for that, but yeah, it would happen late. That would definitely involve scalability. But the underlying problem with scalability in Ethereum is it's not consensus algorithm like some chains, maybe Avalanche would tell you. Consensus is not the bottleneck. Chains like Solana will tell you compute is the bottleneck, and they are improving compute. That's not the bottleneck for Ethereum either. You can easily process more transactions in little time. For example, Polygon is doing with their lower block times and stuff. uh, you can definitely parallelize things which will improve compute, but it's not the immediate bottleneck. The bottleneck really is data availability, which comes really from the state size and state growth. If you want to be a long term blockchain, you can't increase your state by like 1 gigabyte every day. uh, in a few years, nobody would be able to run that blockchain, and you would just get stuck forever. So yeah, like the main challenge for Ethereum is to figure out how to slow down their state growth and focus on data availability solutions. So that's where like sharding comes in. The goal of sharding is that every node will not have to store all of the state. They would only have to store the state that belongs to their shard, and any other state they will fetch from other nodes. So this will definitely help. Other solutions are being employed, like state rent was being researched heavily about 2 years ago. although the plans have almost been dropped at the moment. It was like the users, they didn't really want state rent, so that's on hold. But there are more plans like uh, stateless clients, as you mentioned. That's definitely one area of active research. If we can make the full if we can make the nodes stateless while still offering the same functionality, then we can worry a little less about state growth, because we won't necessarily need to have full nodes at that point. If there can be like people who are storing data in some way or another, who are like partially storing data, which we'll solve with like some data availability solution. Maybe the state would be put on IPFS on Bit or BitTorrent or something like that. Polygon's Avail is building something similar on top of IPFS, so they are trying to solve the data availability problem. But yeah, that remains the biggest challenge at the moment. How do you increase your throughput scalability without increasing the costs of running the node by a lot?
Right, very true, very true. I hope Ethereum works on that and fix it soon, because the user base is still very much big on Ethereum. And I guess with that, we all are done with our questions. So on an ending note, I just want you to maybe give some advice to new learners or new joiners who want to jump into the Web3 world, Web3 security. Because I've seen, just based on some experience, I've seen that some new guys are just joining because there's a higher reward available in the Web3 security, and they're not much into learning stuff, exploring more into it. So what do you want to give as an advice to those people?
Yeah, sure. So, my first advice would be that if you are new to programming itself, then don't start with Web3. There is very little learning resource available in Web3 compared to the Web2 world. So, if you are completely new to programming, start with a Web2 tech stack and language. Python and JavaScript are two great starter languages. Once you learn the basic concepts of programming and like building applications and computer science and all, then you can start with Web3 world. When you get into Web3, I would recommend first learning about blockchains. Don't care about smart contracts slash solidity slash security right away. Just learn about how blockchains actually work, how they make the system decentralized, and stuff like that. There are multiple resources. So there is this book, Ethereum book, I'm forgetting the exact name, from Gavin Wood and Andreas. um, it's a good
It's mastering Ethereum. It's
Oh yeah,
mastering Ethereum.
exactly.
Yeah.
Yep, that's correct. It's a bit dated right now, but it's still like one of my favorite resources to learn about blockchains. So you can start with that. You can watch some courses on Coursera or something like that. A bunch have popped up now. Ethereum org has a new learning page on their website. You can start with that. So learn about blockchains first. Then you can get into smart contracts if you want to. If you want to get into the code development, then that's a different story. But to be honest, the money is at least right now in like smart contracts and DeFi applications. So assuming you'll get into this space, start learning about Solidity. Another candidate there would be Viper, but there are more Solidity resources available than Viper at this moment. So for newcomers, I would recommend getting started with Solidity. Learning the basics, reading the documentation. Sure, Ethereum Yellow Paper is a nice resource as well. So yeah, learn about Solidity, and look at current major DeFi applications to learn about finance a little. The thing about DeFi is that you don't only have to know Web3, you have to know everything. You have to know the finance primitives, have to know the coding, you have to know security stuff, you have to handle risk management, you have to do everything if you want to get into the space. So yeah, start looking into existing protocols, look at their code base, see what they're doing, how they're doing, look at the research they might have published around their security. That would be a good learning resource. Then I'll highly recommend to do CTFs. I recommended. I think they are one of the best ways to learn security. And after that, you can decide what you want to do. You can do bug bounties. You can launch your own protocol. You can launch. You can do like audits on Code Arena or something like that. Whatever like interests you the most, you can get into that.
Wow, yep. That's like you can say a detailed approach that everyone should follow, and that's the best one I can say. And yeah, I guess with that, we are all done. We have a question from Gene is asking like, are you offering mentoring service? I'm
Not
not sure, my friend. He has lots of work to do.
Yeah, not at the moment, but definitely like if I hire more interns or anyone like that in the future, I'll definitely let everyone know. And that being said, like if you ever come across any problem that you want a solution to, I'm always available through my blog or my Twitter handle. Feel free to reach out.
Right. Yes. Yes. He's uh, like he always in a state of helping the community. Whether you can reach out to him on Twitter, uh, the response might be less, a little, a little bit late, but yes, we can understand he has lots of work to do and lots of research that he's doing. And yeah, I guess we can take one more last question. So is Manish is asking like, what do you think about intersection of crypto and AI ML?
Yeah, definitely. So there are multiple use cases where like which would come handy with crypto and AI/ML. The first use case, which is already being heavily used, is really KYC slash AML. So people, companies like chain analysis, they are going heavy into machine learning to figure out like any bad actors in the space. So if anyone is like really interacting with a institutional thing like a bank or something like that with crypto, the bank wants to know if that crypto is clean, if it has not been stolen or anything like that. And AI/ML can definitely come handy. It can pick on patterns which can point out like bad actors in the space. It's being used heavily. And the other use case I'm like pushing for these days is decoding of transactions that you sign. So if you have used MetaMask to access DeFi applications, you would have noticed you have to sign some data every time you do a transaction. But just looking at the MetaMask, you have no idea what you are actually signing. So yeah, like uh, AI ML can definitely be used there to build some sort of an antivirus which can detect like weird behavior, weird signatures, and like fraud detection. Obviously, the first use case, that's the right word. Here with MetaMask, it would be sort of fraud detection, but for the end users, if the wallet can warn a user that hey, you are listing your ape for 1 cent, it sounds a bit low than the market price for a bored ape, you might want to reconsider. That sort of warning and everything can eventually happen with AI/ML. It will take time. It will take years and years to build, but that's would be a one very interesting use case.
Right, and maybe someday we can possibly stop some attacks with that as well. Hoping for the best in the space. But yes, I guess we are done, and I just want to say thanks to you for taking out some time and being a part of Unchained. It was completely an honor, and yes, some of the coolest advices that you have given, like from this session. We discussed about the security trilemma. We observed what is going on in the ecosystem, different chains. We have, I guess, literally touched many of the new topics and that are really required to discuss. So just once again, I can just say thanks, and thanks for being a part. And I just want to say, don't stop here. Just keep on doing your research and sharing your information. We all need those. And yep, with that, I would like to say goodbye to you and have a great day. And yeah, I'm looking forward to see you soon, probably in another event.
Yep, sure. Thanks for having me. It was pleasure talking and some wonderful questions from the community. Have a nice day, everyone.
Yeah, have a nice day with it, and see you on the other side. Bye bye.
Cheers.
Whew. Wow, that was nice. That was amazing, right? So I hope I'm visible. Uh,
Yeah, Vijay.
not so fresh. Like it's a bit early in the morning. So I'm just trying my best. But yes. So there we go. We had Mudit sharing the stage with us, and he had given us some of the best advices that everyone should be following. It doesn't matter if you are already in the space, you are a professional, you want to jump into the space, looking forward into the Web3 security. You don't have a path basically, and you're just trying stuff. And one more thing that he said, like if you are coming in just for the bounties, just give some time. Just
Yeah,
wait there, give some time, get into the security world, learn about Solidity, Viper, and probably Rust if you're into, like as Timu said, alternative way to jump into Web3 hacking. So yes, so all this stuff, just consider that, and the resources that have been shared by him. We will be linking those down with the slides, with the slides, and you probably will definitely benefit from all of these resources. And with that, sorry, we have a Sleepy. We have Sleepy. Is it there?
no, he would be doing this in quite a while.
Okay, so we have Sleepy. I think you must be following him from the Twitter. So he's a very active person. He also posts a lot about the security stuff and actively participate in the security events. And yeah, we can say he's like us, like a cool new, a crazy kid in the town and just supporting the community. So we all are waiting for him to join. And let me know when he's there. Till then, we can just take a quick break of 5 minutes.
Yep.
Right.
We will be just back in a short while.
Right.
People.
And I hope we can just one more time roll over the speakers lineup. The speakers lineup we can roll, right?
Sure. And
Yes.
guys, just remember to like subscribe to our YouTube channel to stay
Right.
informed. And of course, like do try Cypher Shasta. Like I would be linking them the link down below. Uh,
Right.
newly a CDF platform, which would
Right.
definitely help you in the journey.
And if you are looking forward for the audits, definitely check out QuillAudits. We have done some exciting projects. It's like right now I can say a number if you want. It's like we have done some 300, 400 plus projects, and some of the very big names, some of the very cool protocols. So I would say definitely check out QuillAudits if you are looking forward for an audit or maybe a discussion, or because we do research as well. So if you're looking forward to it, do check out.
Yeah, so just stay tuned, everyone. And with this, we are just moving towards the last talk of Unchained
Right.
2020.
Last but not least, my friend. Yes.
And with this, the event would be over, and we'll catch you
I guess Sleepy is going to make some cake. His title is pretty much interesting. So okay, making the perfect cake. All right. We're looking forward for the cake, and hoping for it should not be pancake slap. But yes. I hope very DeFi pun. Yeah, but sorry. Yeah. My puns are bad like me. Yeah, so just know that. All right. So I hope people will be joining in a couple of minutes. Right. We can roll our speaker lineup real quick. Hey, hi, Sleepy. Can you hear us? Okay, so Computer Evolve is saying, hey, Sleepy, don't panic. Yeah, we all are here to cheer. Yep. I don't know whether we are audible. I guess we are.
See.
Nope, we can't hear you. Just make sure you have given the permissions to your browser, maybe, to maybe record your audio, probably.
I
Yes, now we can hear you.
Yeah, it's I'm not sure oh, okay. Okay, that's so I can start sharing my screen now, right?
Right, right. Yes, please go
Okay.
ahead.
Okay. See. So can you guys see everything?
Yes, we can see everything, and everything is nice and visible. So, hey everyone. So, right
Hello?
now we have with us Sleepy. He's probably, you can say, the most active person. And yes, a security researcher from Consensus Audits. And right, yeah, he's a pretty cool guy. So, we are leaving up to him to introduce about himself and share the knowledge that he's perceiving. And yep, looking forward for the amazing talks. Sleepy, all over to you.
Hello? Huh. I think like my audio just
Yes,
cut
yes,
out
we
right
are.
now.
We are,
But
yeah,
anyway,
I got it. Yeah, we are able to hear you.
and well, these these technical difficulties. Okay, I will be presenting this is meant to be an introduction to common DevSecOps techniques as applied to decentralized applications. So we begin. I'd like to introduce myself further, but I think the staff already did that for me. Most of you will know me by the pseudonym Slippy. I'm a junior security engineer at Consensus Diligence, the SKIDL, which is meant to be a collective to onboard newbies to all of this. So if you have a question later, you can either ping me in the RazzorSec Discord or like that server. I'll share the link later. I'm acquiring a station, which basically means I'm trying to terrorize. I'm also a cypherpunk, not a cyberpunk, despite what the trailer said. And I used to make some EDM on the side. So before we start, I want to clarify what blockchain security is. Same thing as smart contract security or Web3 security, but that's not really it. Most times that's just meant to be more than just smart contracts. It extends across the tech stack to include clients for maybe ETH2, the merge, decentralized applications, smart contracts, and the core protocol itself. I'm sure a lot of the speakers before me have taken you through a few developers and often most smart contract. Now, most security engineers doing this have to worry about their dApp front ends and the smart contracts. So in other words, that's broken down into web app and smart contract security. So what's the problem I'm trying to address in this? The problem is most we as in Ethereum and just the blockchain ecosystem in general have done a very good job of focusing on security. But the problem is it's just been a singular focus most of the time on just smart contracts, and that's typically post development rather than during the development cycle. And I actually think it should be overall, depending on that you're using, and you may include like front ends or even like cloud security into it. But I'll actually remark that I'm kind of disappointed if you involve the cloud in this, because it's meant to be decentralized, and in any kind of centralized point of failure is well a disappointment. So even like at times nodes aside from the base implementation, they can be misconfigured, and that could lead to security issues down the line. If your organization wishes to use your own nodes to connect to the blockchain over products like Infura, consequences, security reviews typically take longer to complete due to complex vulnerabilities found, and even just mediums that weren't caught far left in the development cycle. So major bugs discovered close to launch are often more expensive and harder to fix, requiring massive rewrites of a code base, and this can get very expensive very fast, especially if your team is relying on external contractors to write your code. As you know, it's very hard to come across senior Solidity engineers, and so most times they will be offering their services as freelancers. And even launch dates can be pushed back because a bug is taking longer to fix, and that will often reduce the morale of investors. As you know, investors in in the system are kind of short-sighted, and they're always like hopping aboard the next type chain. So you might lose them if you fail to deliver on time. And of course, ignoring security in one facet can be just as disastrous. For example, we had the Badger DAO hack last year in December due to compromised API keys, which allowed the attacker to load a malicious script into the front end and deceive users. And just like that, around more than $100 million was lost, which could have been prevented. So what are the solutions to this problem? Solutions, I think, mainly security must be baked in as a crucial ingredient rather than the frosting, following the theme of my title. And so what does that mean? Essentially, we need to shift security left. So what does that mean? Typically, I actually covered this before, but typically, security reviews are shifted right in the development cycle, close to launch, often with disastrous effects. And so the basic idea of it is to start early and continue reviewing and fixing. So shipping faster and having more secure products. So how can we accomplish this? I actually broke this down into 5 steps, and that consists of internal security reviews and security development, automated analysis, or your continuous integration or deployment pipeline, external security reviews and consultation, and post-deployment, and some miscellaneous tips I'll go into. So let's get into that. First bit here is internal review. And of course, you should be your developers on secure coding and best practices. That is to say, the consensus Ethereum best practices, bits building secure on screen. And I'll let them later in the chat. And at minimum, you should have at least one security engineer or and another one, ideally monitoring your website for security vulnerabilities. And we need to have in-house security reviews or audits after every, and I'm actually not really talking about automated analysis at this point. I mean, a line review for possible for those of you who don't know Pqr Process, it's the number one best security tool for penetration testing web applications, and it's a staple in the wider security industry. Can't afford that for whatever reason, which is pretty shocking considering you're a DeFi project. I will also be sharing the link later on for that. us on to the next step, which is automated analysis, or your continuous integration / deployment pipeline. And so I will do the web app easy to run tools in your that might be Travis, it might be GitHub Action, it might be. And Consensus Diligence actually hosts a bunch of tools that will be helpful in doing that. One of them is our Pqr service. It's called Mythex. No doubt most of you have heard of that. And Mithril, which is actually open source. Mythex is paid. And then of course there's Slither from Trailer, our in-house project called Harvey. And
Hi, Sleepy. Sorry for the interruption. Can you hear me?
And basically, it allows you to write greatest things about it is it lets you fuzz test with different fuzzes. It doesn't matter if it's diligence fuzzing or it's hidden out or something else. And so continuing on complex application logic, because that's typically where things go wrong. Diligence fuzzing is a good day, the best choice, but
Hey, Sleep.
of course I'm biased, as you know, but it actually has been reported to have and get in an hour of running. So, and additionally, if you guys can, you should also integrate formal verification where it is needed on critical functions due to time constraints, because formal verification is a technique that actually takes a long while to complete, and that's why it's not optimal to use it on audits which are typically 2-week engagements. So I think earlier on some took you through formal verification using the KVM. So I expect you guys to be semi-acquainted. Then moving on to web apps, you should actually test Suite Professional's automated scanner, and then dig deeper with its array of manual and semi-manual features. Potentially, you should invest in Burp Suite Enterprise or even Nessus. For those of you who do not know, Nessus is a vulnerability scanner. It's also one of the most well-known and well-used when it comes to enterprise security. I'd actually ask you guys to research more on this subject, because the majority of my knowledge of web app security comes from an offensive perspective. So I'm not able to make good general recommendations when it comes to defense, unless I've personally tested your security myself. And so that will bring us on to the next item, which is external security reviews and consultation. So ideally, you should account for both smart contract security reviews and their off-chain components, be it the cloud, front-end, whatever. We'll just classify that as infrastructure security for now. And often if you're having trouble implementing a technique, like, or maybe your developers are stuck and don't really understand how to use this techniques, you should often reach out to a security firm. I'm going to be free, but well, it's better than nothing. And actually, Trail of Bits actually, I think, 3 office hours, about 1 hour each. So if you're having trouble with their tools or just need some help, you could book a time with them on Calendly. I remember them sharing a link in a repo somewhere. It's Critics Awesome Security, Awesome Ethereum Security. I will be sharing that in the chat later on as well. And of course, I have to plug my own firm. Otherwise, it wouldn't be a presentation by a member. If there wasn't. So consensus diligence actually offers consultation, infrastructure testing, as well as smart reach out to you. So moving on to post-deployment considerations. Obviously, you guys should set up a bug bounty program to incentivize security researchers and potentially even sway uh, black hats from stealing your funds, because obviously laundering all.
Hi, Sleepy. Can you hear us? It's like there are some issues with the network from your side.
There seems like a network issue from the speaker side.
Guys, just give us a minute. We are trying our best to fix the issues. All right, Sleepy, you're good to go. I hope my screen is visible. Okay, our name, I guess we can join for our final words.
Yep. Hey. Yeah. So hey everyone. I mean, we just ran into some technical issues with the speaker, so
Right.
we won't be able to present at the moment. But rest assured, we are working out, and we will definitely upload the recorded presentation on a YouTube channel in the coming week. That
Right. Right.
done. And regarding the questions that you may have, please feel them to drop in the discussions channel of our Discord. We will connect with the speaker and answer them there.
Yeah, perfect, perfect. Yep. So once again, yeah, sorry guys, sorry for the technical issues, some network problems. Yeah, we can understand it, like it happens, right? So yeah, not much of a big deal. We will be seeking his recorded talk, and we will be seeking your questions as well, so that we can just attach them together and we'll work it out. All right, so feel free to drop any of your questions in our Discord in the community, and we'll forward them up uh, to Sleepy, and he will definitely answer all of them, right?
Yep.
So with that, I guess this is the time to wrap our event. Wow, it was phenomenal and fantastic. We started with the Adrian talking with a couple of DeFi bugs, smart contract bugs, and moved on to Roa Snagpal, covered like probably like all
Whole
the chains, right? All the chains that we know, like practical security, like of nodes, like how you should be configuring your nodes as well. Talking about Pablo, let me just go one by one, like what we have seen, kind of a recap. That would be awesome, right? So we started with Adrian, right? We started with Adrian, the DeFi security triager at Minify. He presented over some smart contracts, and he has given us a tour basically, and presented us some well-known, like very popular smart contract bugs, and given us some best practices and advices that we all should be following and considering, whether we all are like whether like if we are professional, or doesn't matter, like if you want to jump into the security world, those are some of the advices that you all should be following. And yeah, the mug that we remembered, king in the north, yes, so that was very cool. Moving forward, we had Pablo. So Pablo presented over let me just share my screen. Let me just go over to what we had. Let me just do it. Right. Let me just share it. Right. I hope it's visible, right, Arunim? Just give me a yes or no.
Yep. Your screen is clearly visible.
All right. So then we had Pablo. We discussed over the cloud vulnerabilities. He had given us like another cool aspect that we often miss out. We usually focus on the smart contracts, the blockchain itself, and we like usually miss out the off-chain components as well, which are the centralized part actually, like the cloud configuration, the oracles which are sending the prices. So what if there is a bad configuration and you are getting an unintended price that can affect your smart contract and probably uh, ruin a lot of your funds, or probably uh, like yeah, many bad things that can happen, right? Many things that could go wrong. So those were the things that we got to know from Pablo, the implementational and the operational behavior, right? The risk were presented by him. Then we had Rohas Nagpal. We discussed over some practical ways of securing nodes. He probably covered like all of the chains that we know and interact with, whether like Avalanche, Ethereum, Solana, Polygon, Terra, Tezos, like probably everything. Then we have Muhammad, and we had like a setup, the cloud setup, right? We set up our cloud environment, and like I guess there is a need that was very practical and a very easy to follow tutorial for everyone looking forward to have a handy tool like Slither, or you can probably replicate the same tutorial to launch another tool probably on the cloud. It could be Scribble for property testing or whatsoever. Then we have Euron. Yoran talked about scribbling. He has given us new insights of Scribble, like what can we do with Scribble, and like why we should be using Scribble, right? As a part of our you can say auditing process, as a part of our you can say process of security, basically, right? Because testing is again a cool aspect that we don't usually consider, right? In most of the projects. So that is again a thing that supposed to be done. Then we had Rajiv, like the man himself, we know from the security and bootcamp, like talking about the contribution that he have made and the ongoing things that he's doing with the help of security and bootcamp, the races, the cares, the event that is happening are going to happen in the Amsterdam, and yes, so things like that. Then we moved beyond blockchain. We talked about the Hyperledger Fabric security and concept, like a completely new, unexplored domain or say field we saw. And yes, we got many resources to learn from, right? And I hope you all will be following with those and learning from them. Then we had Daniel, right? He like ripped apart a bug, right? Like and I was really amazed. He picked up a bug that was like 24 hours old, right? Just was rolling out onto the internet. He picked up that, given us his approach and given us a mindset that we should be having or following whenever we go and try to hunt bugs. Then we had Andre, Anthropon runtime verification, and he talked about another cool concept, which is formal verification. Formal verification is still not being followed in many of the projects, and it has given us the insights that many of the things can be explored with the help of formal verification, right? So formal verification is also a very cool thing that we all should be looking forward. So that was the end of day one. Now, today we had Josh, right? Josh given us information about entropy and the random numbers. He has shown us some devices that he had made, right? And we discussed about some facts and figures, some cryptographic algorithms. So we discussed about ECC, ECDSA, SEC 256 P one. Uh, the curve that we use in Bitcoin, Ethereum, right? And yeah, so just like that. So we learned a lot, and we know, right now we have a couple of different options. If you want randomness on chain, we have Chainlink doing good. Chainlink VRF is there. The new researches are going on over VDFs and all. So yeah, so all those stuff. Then we had Rex from DeFi Safety. So Rex brought out a cool and a different product that he and his team is trying to build, and he's trying to solve a problem and giving an option of like a trust score for a protocol, like completely different problem, and but a much needed solution, right? So yes, that will help a lot. Like if you are whether you are professional or non-technical person who wanted to interact with the protocol but don't have much idea, right? What is the current state of the protocol, right? What are the hacks that has happened right now recently? What are the things that being patched, right? What are the contracts involved, the team involved, whether there is upgradability or not? So all those factors were covered by Rex. Then we had Timur gave us an alternative path to Web3 hacking, right? We learned about Rust, different couple of resources, so we know it's not just about Solidity. And yes, but you should be learning Solidity and all. But if you want an alternative path, there is one. And for Polkadot, near substrate based chains like Solana, if you want to head over to Solana, you want to learn Rust, he has probably shared like all the needed information. Then we had discussion with Mudit. Uh, we know him like one of the coolest security researcher. He has helped a lot of protocols, saving millions of funds. He is continuously doing that and helping everyone learn and grow. We did discussions with Mudit. We asked many of our questions, and we asked about the state, his experience, his observations regarding different chains, the ecosystem itself, DeFi. Then we have Sleepy, some of the technicalities, and it was a discussion over like baking a perfect cake and smart contract security, like what to be done or what not to be done. But there was some network issues, but not an issue from our side. We will be interacting with Sleepy, getting his recorded talk and uploading that onto our channel so that you don't miss any of the speakers' valuable resource information. All right.